invent an invention that exploits this theory.
Or you could get a grant to do the field experiments.
No, but the question is, can I go to the media and get them excited like they are about flat Earth?
No.
No.
That won't get you any money.
No, I mean,
Probably.
Send it to Neil deGrasse Tyson.
Here you
He'll
go.
red pen it for you.
Here's your business plan, Mr. Slave. Just look at this guy's website.
You could be a guest lecturer at Flat Earth University.
Yeah.
That's a good idea.
No, wait. You want me
he's
to?
He's launching his app November 1st.
Wait, you
Is this one going to dox all of its users?
If you don't pay.
I don't get it. Wait, oh, you put it in the live stream chat?
Yeah.
Oh.
I never use the side chat.
That's terrible. He has a surprisingly good who?
That's if you want to make money off of rubber ducky ether relativity, then that's the market you appeal to.
Wait a minute. The rubber ducky is a good business idea. I can sell rubber duckies to teach special relativity using a rubber ducky. That's a good idea.
You know who? Do you ever watch Ali G? You guys know.
I've seen. I know. I mean, he's like Borat. He's the actor.
Yeah. Well, the Ali G character is the lesser known one that didn't take off as much, but it was equally funny. And there's a great interview there's a great segment where he comes up with the worst business idea possible.
Mm-hmm.
And
it is a curve, but it will meet.
Let me find it for you because it reminds me of your business idea.
Mm-hmm.
And it's a method to avoid.
Mm-hmm.
It's a method to avoid ice cream drooping on your hands. I guess what it is?
Gloves?
Yes, it is. It's a glove. Yeah, it's an ice cream glove that you wear to eat ice cream with, so it doesn't drip your hands. And that's the tier of business idea that relativity rubber duckies are.
No, I think rubber duckies would sell very well.
You've got to be trolling.
No.
I'm ending this conversation. I choose not to engage. You're muted on my end.
Stop.
Well, you could have a whole lineup of the rubber duckies, and you can give them names. This is Feynman. This is Einstein. This is Dirac, and then collect them all.
Wait, Celine, did you mute me? Did he mute me?
No, he did not.
No, I didn't.
Oh, okay.
No, I was. He thought he was asking. He was asking if he was muted on my end, like Glory does.
So, no, actually, it's a good idea. I could sell it. Yeah, it's good. It's a good idea. Didn't think of that. Nevertheless, how do you think you did, C-Line, against your foe tonight?
Pretty good. Could have been better, but.
Mm-hmm. So I noticed that you said you don't have a problem for electromagnetic waves to wave through nothing.
Mm-hmm.
You don't have a problem with that?
No, I don't.
Mm-hmm. Would you say? Wait. So is a photon a particle in your imagination? The way
it's modeled as a particle very accurately, but there's a duality.
Mm-hmm. So all elementary particles are dual waves and particles?
Yes, demonstrably.
Hmm.
Well, bosons anyway, right?
Oh, hold on. Where's the thing?
I think all particles.
Yeah, all particles.
Hmm. So,
All particles that I know of.
Well, what's
so
the difference between a boson and a fermion?
Oh God, I don't know.
boson are force-carrying particles. So the boson
Yes, correct.
exchange, right? So, mhm. So why are these particles limited by right? You agree that all particles are limited by the speed of light when they move, right?
Yes,
Why? What's your explanation? What's why would they?
it's
Hmm.
a law of nature. It's
Yeah,
invariant.
why?
It's a
Like,
postulate.
so it's just a postulate.
It is what it is. That is the speed of causality in our universe.
Hmm. Right, but if you imagine an ether, then right, it would immediately come out of the ether. Like if you imagine that there is an ether fluid in the universe that all these particles are waving through,
Yeah.
you immediately get a maximum speed of propagation of waves, right? So you immediately get a
No, I
maximum.
don't think you do because that's what they were trying to do before relativity came along, and if they were able to do it, they would have just said "fuck relativity" because it sounds insane.
Wait, but you do agree that if you assume the ether, then you immediately get a maximum speed. I mean that
No,
no?
you don't. No, because the problem is that you need to explain why the speed of light is not additive with inertial reference frames or any
Well,
reference frame for that matter.
well,
If I
Yes.
shine a light, if there's an ether and I shine a light on a train in front of me, the light should go faster because of the addition of the velocity of the train, but it doesn't. It can't, because if that were the case, the Maxwell equations would change based on the reference frame.
but my rubber ducky takes care of that, right?
I don't care.
What do you mean you don't care?
I am not going to take a paper based on rubber duckies. Seriously. I'm sorry.
Well, then you're refusing to answer my question.
Yes.
That's called losing a debate.
I'm not having a debate.
That's just losing a debate with, when you lose a debate, you usually say, I'm not debating. That is what the loser usually says.
Okay, that's fine. You want to say that you baited me into a debate and I didn't answer you, and therefore you win? That you can do that.
I didn't
But
say,
the record.
I
The
didn't,
record will show that when we formally
you can't-
debated, I trounced you. So
Yeah, you can't just redefine a conversation as a debate.
well, I mean, he redefined all of physics, so it's not much of a stretch.
so you're unwilling to answer a simple question.
I'm unwilling to engage with you on your rubber ducky theory. I
Why?
don't think it is because I
Why?
don't think it's worth my time.
Well, but why not? Or, look, let's ignore my rubber ducky. I'll take the rubber ducky off the table. So, right. So the problem you're facing now is why is the speed of light a constant for
It's
all
postulated as
No, but you're right. But I'm telling you, well, if we assume that the universe is filled with a fluid called the ether, then we get a constant speed. But then you're saying, yeah, but if I'm moving through this ether, then I should get additive velocities of this wave.
Yeah, well, if you don't postulate that the speed of light is constant, and then derive a theory on the basis of that postulate, then it's logically contingent that the normal rules of physics apply.
But okay, but so you're claiming. So how do you measure the speed of light? Let me ask you that. How do you measure the speed of light?
Well, that's the issue, and that's the proof of relativity. You cannot measure the one-way speed of light.
Well, but we
Think
have
about it this
measured.
way. If I take two clocks,
I didn't say one way. I'm just asking. Right, we're
we
just.
measure the two-way speed of light. The reason that we can only measure the two-way speed of light is because relativity is true, and there's a relativity of simultaneity, and the clocks become unsynced when they're moved or moved into a different gravitational potential.
No, let's just talk about special relativity. So, no acceleration,
So then
no gravity.
no general relativity. Okay,
Yeah.
so then, yeah, nonetheless, you can't measure the one-way speed of light. It has never been done.
I'm not talking about that. I'm just saying. I'm talking about the speed of light. I don't care how we measure it. So, right, you're saying it should be additive. The fact that it's not additive is weird.
Correct. Because
Okay.
everything else, a sound wave is additive, right?
No, it depends on the measuring equipment, right? You don't want me to use my analogy, so I'm not going to use my analogy. But
All right, fair. Is it though, like, if you take a loudspeaker and you put, I mean, there's Doppler shift, which is different, but isn't it the case that a sound wave launched from the front of a train travels faster because of an additive velocity on the compressive wave moving through the medium? Or is that not the case?
Well, that's
really basic physics that I should understand, but I don't.
I mean, let's imagine the train is moving from the left to the right, but it's far away from you. So we're avoiding Doppler. So the train is just moving with respect to you, but it's far away from you. It's moving from left to right, but far away. So there's no Doppler effect. And yeah, I mean, anyway.
I don't see how that works.
What? No, all I'm saying.
By the way, real quick. So the speed of sound in a given medium is fixed. It will not go faster. So from a train, you get a higher frequency.
Right. If there's wind blowing, then that could add or subtract from the apparent speed of sound to a stationary observer.
Because the wind is the medium, so if the medium is moving. But the speed of sound coming off the front of the train is not increased by the speed of train, because that's why you can approach the speed of sound and go past it.
Unless the train is moving faster than the speed of sound.
All right.
Anyway, so if we use the speed of sound or the speed of waves in water, right? That is a constant that we always measure as a constant. Let's assume a constant speed of, all the conditions. Let's talk about the speed of sound. So let's assume a constant temperature, density, and the rest of it. So, right, we would always measure a constant speed of sound. So so if we assume a medium, we get a constant speed of waving in the medium. So why would light be different?
Well, one thing about the speed of sound is it's dependent on the density of the air. So the speed of sound at jet aircrafts is slower than the speed of sound at sea level.
I'm ignoring I'm ignoring density. So given a constant that, right, et ceterum paribus, as we say, all conditions are alike. So the speed of light is a constant. The speed of sound is a constant. Once we assume a medium, a constant medium, then the waving in that medium is of a constant speed. Right? For any wave that we know, why would
Yeah.
light be different?
And that disproves ether.
Why? I mean, so isn't it exactly the same for light waves? If we assume a medium, we get a medium for light, then the light waves should go at a constant speed. So doesn't the ether give us immediate constant speed of light?
I don't think so. I don't think you need the ether for this.
I mean, if you don't assume the ether, then you have to postulate that the speed of light is a constant. But if you just assume the ether, then you don't need to postulate.
Or we could just assume the speed of light is constant.
But fine. But isn't it simpler to, right? We know light is a wave. It's waving through something. So it's waving through
We don't know that. No. That
What do
is
you-
your claim.
What don't we know?
You're asserting that repeatedly, constantly.
Wait, what don't we know?
We don't know that light is moving through something.
Then what is
or
wave?
your definition of something,
No.
which you were very particular about. We've talked
No.
about this.
Hold on. So light is a wave, right? It exhibits, right? We know from Young's experiment that light, right, goes through two slits and it creates interference like waves do. So light seems to be a wave, right?
Sure.
So what is waving, right? If it's a wave, the definition of a wave is something is waving.
Do you remember what I told you when we talked about this yesterday?
I'd rather you just answer the question.
You don't remember, do you?
Well, I'd rather you not reference me. You know, it's the usual conversation. Please, no referencing. Just answer the question.
Well, I'm not sure that I'm willing to because
That's
I spent
fine.
an hour and a half listening
Yeah,
to you
please,
monologue
please, no,
and
please,
say the
please,
same
please,
darn
please,
thing.
please stop. Just let's have a conversation.
And then you
Just answer
then you
the
walk
question.
away
Just
and
answer the
pretend
question.
that you're being persecuted
Okay.
when
Oh
you're
my
not.
God! Please just answer the question. Please don't destroy this
Okay,
conversation.
I'll
Just
answer the question.
yes.
The
Thank you.
electromagnetic field.
Oh, okay. So what is waving?
The electromagnetic field.
Well, okay. Would you say that we can name whatever is, so something is waving, right? It's not that there's nothing there. Something is waving.
Is a field something?
Why are you refusing to answer the question? Why are you
Because it's contingent on your definition of the word something. You
My
go
definition?
into this because yes, this is a semantic argument that you like.
Would you stop referencing me, please? Let's just have a conversation.
No, we need to agree on
Why-
what words mean. And this is a trick that you play, and I'm trying
Stop,
to tell you
please
that
stop.
I've seen it before.
Why is it so? Look. Let's just talk, please. Not about me. Stop referencing me, please.
So
I'm
a
not.
wave is waving through an electromagnetic field. How's
Okay. Okay, you'd agree that it's okay. Fine. Would you say that instead of an electromagnetic field, we can just call it something else? It doesn't really matter what we call whatever is waving.
that? An EM field. How about that?
Right, we can call it anything, right? We could give it a name. Whatever it's waving through, we could give it a name. Like, whatever you're saying, that's many words.
Well, but if we gave it a name, let's say we called it gravity, then that would be misleading and confusing.
Correct.
So names
Correct.
do matter.
Right, I didn't mean to call it gravity. I meant to call it something else.
Ether.
Yeah, we could call it ether. I mean, that is what everyone called it until basically 1905.
Because they couldn't find it.
Well, we can come back to finding it or not. We can go back to that. But right, it's one word that everybody referenced when they talked about light and electromagnetic waves. And then all the elementary particles would wave through this thing. Right? Right? You agree that an electron it exhibits wave behavior. So
It
again,
exhibits particle behavior.
yeah, fine, but what is it waving through when it exhibits a wave-like behavior? What is it waving through? What is it a
The
wave of?
electromagnetic field.
An
It
electron?
definitely
An electron is not
has
magnetic.
electromagnetic field components. I'm not sure that like fermions, when they exhibit wave like behavior, I'm not sure if it's the same as the EM field. It may be like a quantum field.
Sure.
Elon, do you know?
Right, but all those things that wave.
The exhibiting wave-like behavior does not mean that something is waving. That's your key misconception.
Well, they threw an electron through basically a double slit, and they got an interference pattern.
Yeah.
So that implies wave-like behavior.
Wave-like behavior does not imply a wave. Does not
So
imply something is waving.
Wait, so how did you get how is an electron going through two slits at the same time and interfering with itself?
Maybe
So,
it's
like,
breaking
this is
up
the
into a
big,
bunch of
great
little.
question of 20th century physics, isn't it?
Wait, yeah, because we're not assuming ether. But if you assume ether, the answer is right before our eyes.
Yeah,
No, it's
if-
not.
What do
No,
you mean?
if
no.
you assume ether,
was
then-
rejected because it did not answer any of this.
We can come. Wait, what? Hold on. If we
it
assume,
didn't answer the question, right?
wait,
So-
let's see. Wait, let's see. So if we assume ether and the electron is waving in the ether, and the electron is a wave, and it's going well as a wave, we expect it to easily be able to go through two slits at the same time and then interfere with itself and create an interference pattern, right? That's obvious. That part is obvious. I agree that we now have a problem in the detection. The detection gets only one electron, but now we have to deal with a wave that seems to spread. That's an issue. I agree. That is an issue. I have not completely resolved. But we're able to let a single electron go through two slits and interfere with itself. That's most of the way through the problem. That explains most of the issues in any double slit experiment, I would say.
How do you figure?
Yeah, electrons exhibit wave-like behavior.
Right. So an electron, let's say it's a wave. As a wave, it's able to go through two slits at the same time. There's no issue. And then it interferes with itself. Once it's past the two slits, it's actually now two waves, and they interfere with each other, and they create an interference pattern. The constructive and destructive features of interference pattern of a wave. So it's beginning to make sense. I agree that it doesn't completely make sense because we're not getting from one electron a spread, a complete interference behavior. We're getting still one dot, which is weird. I agree. There is some weird.
Do you agree that we can count electrons? That they are quantized?
Yes, of
They behave
course.
like particles sometimes?
Of course, yes. I wouldn't call that so much a particle. I would call it a quantized wave. So electrons seem to be quantized waves. I wouldn't say that they behave like particles. A particle doesn't have a speed limit, for example. I can push a particle to any speed I want. Why would an electron not allow me to push it beyond the speed of light? That would be weird.
So like this is basic
But
relativistic
why?
mechanics.
Yeah, but if it's a wave, then of course I cannot push it beyond the speed of the waving in the medium. There is a maximum. Mhm.
Guy, what you're doing is this. You're saying reality exhibits this behavior. I don't understand why it exhibits this behavior. So I'm going to compartmentalize the pieces of behavior that I can explain with ether, and I'm going to say reality is made of ether.
No,
And then the parts that I can't explain, I'm going to kind of ignore.
no.
Yeah, that's what he's doing, and which is more than most like creative folks get. Like,
Well,
I think you're more creative than most.
thank you, but I said no multiple times, and you keep talking past me as if I'm not in the room. So please stop.
Well, your
Well, you
behavior at this point, your behavior is getting you the results you want, Mr. Slave.
okay? So
If you don't want
you're
these
speaking.
results,
Well,
you would
you're speaking.
change your behavior.
Okay, so you spoke, then your friend spoke, then you're speaking, and I keep trying to answer, and you're not letting me answer, and now you're talking about me, which I please ask
I
you many
talked to
times.
you, and
Please
I'm
don't
telling
talk.
you what.
Stop.
I'm
Let me.
telling
I
you
did
what
not.
it
Okay. I
is.
did. Look. Stop. Please stop. Anyway, so the answer is no. I. I don't like. I look at reality. I don't know what it even means to look at reality. I see the data. I see the experiments. I see the results, and we have, I would say, two ways to interpret reality in order to interpret the experiments. And so one way is that there is no ether, there is a vacuum, and there is a magical speed limit. And I don't know, it's all weird to me. Another way is to assume an ether. Immediately I get the constancy of the speed of light, and that everything is now a wave in this medium. So I immediately am able to pass an electron or a photon through two slits and get an interference pattern. I can explain much more using the ether than without the ether. That it's just a better explanation. It has less problems. It's less problematic.
It's got one
You
very
can't
big
explain
problem.
anything.
I can explain how an electron can go through two slits at the same time. Like if I assume it's a particle, then it's weird. But if it's a wave,
Well,
then it's easy.
if
Okay,
you
but
assume that ether can be both created and destroyed,
Well, we can come back to that, but let's just deal with let's say any two slit experiment. So two
no.
slits.
Listen.
Mhm.
So, the way that you're behaving is not conducive to the results you say.
Please
you
no
want.
meta. Please no meta. Please just
I'm
we're
giving-
having
I'm-
we're having a
I'm giving-
discussion. Just
no,
just
no,
just
we're
talk
not.
about
We're in the meta.
let's talk about the topic. Stop talking about me, please.
Mr. Slave, we have listened to you monologue for hours
Just don't talk about me.
and you keep saying
Just
the
don't
same
talk
thing
about
over
me.
and over.
Yeah, just
You
don't talk
you
about
do
me.
not actually
Don't talk
explain
about me.
anything.
Just don't talk about me.
I'm talking about your ideas.
Go
Your
ahead.
ideas do not actually explain anything about physics.
Well, answer the
Your ideas are
question.
not
Well, I made a
new.
point. You're
Your
not.
ideas
You're
are
not
at
answering.
least 130
You're
years
not
old.
answering my. You're not answering. You're not responding. You're not responding.
What's the question?
I said any two slit experiment is better explained with the ether than without. At least the first part, where you're trying
Okay,
to Wait, hold on.
So
Hold on.
how are you smarter than all of the 20th century physicists? What did they not
Let's
understand?
let's not talk
Because they
about
were
me.
very
No,
familiar with ether
let's
theory.
not talk about me, please. Let's not talk about me nor them.
Okay, so
It's
what
now
is your
between.
fundamental
It's
insight that none of the
it's.
20th century
I don't
physicists
know.
have?
I don't know. It's between
You
me and
don't
you.
know. That's right. Because you don't actually have any insight into this problem.
No, please stop talking about me. Just
Well,
answer
he's not
the.
talking about you. He's saying the ideas you're presenting. What about these ideas is these other people? And then
That's
you're
still.
like, you're going
I
off
don't
about
know
me.
anything about other people. Right now, I'm talking to a person. It's between me and him. I'm offering you know, I am familiar with the two approaches, with the ether, without the ether. I used to believe there is no ether until a couple of months ago. And then one day I said, wait a minute, with the ether
You're just
things.
sucking everyone's energy off. You're doing what people are complaining and telling you not to do.
No, he's talking about
Give them
himself, and then he gets mad when
the
other people talk
conclusion.
about
Give
him.
them the so what. Sell them on it. Be a man. Sell them on it.
I'm trying. I keep coming here
You
and
can't do it, can you? Just complaints. Yeah, there's a lot of salesmen that can't sell.
Anyway,
Sell them on it.
all right. Anyway, so I'll sell you. So I used to believe there is no ether. I used to be like the rest of you. I used to be a
Don't
normie.
talk about yourself.
Stop. So I used to
It's a
believe.
fair point.
It's okay if you can't do it now, bro.
All right. Well, the poll has concluded.
Oh, they muted me.
If I
Wow.
get flack for that, that's fine.
Oh, was there a poll?
Wow. They muted me? Wow.
I don't know. I mean, if he's just gonna monologue and nobody wants to hear it, like at a certain point, I have to moderate, right?
Like if he actually had some new interpretation or even an interpretation whatsoever, I'm happy to talk to him for another hour. But like when he says he speaks as if he doesn't know that people have considered the quasi paradoxical nature of the particle wave duality, and it's like that's the last 100 years of physics. All of the weird quotes you get from the physicists 100 years ago about how insane the universe is comes from people banging their heads over the table over the double slit experiment.
Yeah.
I mean, how many times have you heard flat earthers, bring up something that, some early 20th century physicist?
This is incredible that they muted me. Like, finally, we're beginning to have a minimal discussion, and they mute me. It's like, it's really incredible. It's really incredible. Especially after Sealand debated someone and like he's open to actually debating this topic. Most likely consciousness exists as a morphogenic field that could represent your concept of ether. No, I no, consciousness has nothing to do with it. Consciousness is very simple. Consciousness is my day job. Consciousness, I solve that. Like that is the simplest thing to solve. No. Anyway, this is like fascinating how I'm unable to get to these people, and they take it. It becomes personal and really strange. Okay, whatever. There's nothing I can do about it. I wasn't gonna debate it again. I'm actually really. I'm surprised that they muted me. This is really surprising. This was actually going very well. It's like really surprising. What is Gamma? Oh, Gamma is not here. Really funny. On this server, I'm also muted. Yeah.
Way with the mind.
Yeah, I'm muted. So it's really. Oh, they stopped. No.
On the doctrines you hold, the person you are, the soul you are, is inherent.
Let me ask him. Why didn't you warn me first? You need to warn me first. Please unmute me. I'll stop. But you need to warn me next time. You can't punish before warning. Yeah, and let me see.
And love your brother and serve your brethren instead of serving yourself all the time.
That is a doctrine.
You can do that without, like, a doctrine is something that you are taught and that is written. A person can come to that without having a doctrine.
No, they have to be.
But notice that 30%, 2 votes. So one person, Northern Rebellion, just 5 votes. Nico, Sea Lion Prime himself, Carnivore, who I mopped the floor with. At least we know. It's the guys that I was debating. They don't want to debate me. Mostly. Really funny. It's the guys who are like Carnivore. Wait, there's Carnivore, there's Omnivore. So I mean, what are these? I don't know which one is which name. Like Marsh, who's Marsh? Okay, so he didn't vote against me, even though he's like my enemy. So Nico, who is he? I don't know. Anyway, this is a waste of time. I don't want to waste my time. What is this? Okay, he's not going to unmute me, so fine. It's fine. Look, I'm not going to convince these people. I'm not going to convince them, so I'm not going to waste my time. Let me see. So Anya says, well, good luck, Mr. Slave. I hope you're able to express your ideas sometime. Cheers. Yeah, it's fine. Your ideas may be better served just presenting them solo and letting people converse after, because these folks don't seem up for exploring your... Yeah. It is actually one of the better one of the only servers where I do get to present my ideas. So it's better than it's the best I can get at this point. It's fine. And I did meet an actual physicist with whom I've had a very lengthy conversation with. Tapioca Weasel. I spoke to him at length multiple times, and he's very respectful, and he usually defends me more than anyone else. It seems to be. Oh, there it is. Let me get back in.
Yes, I am, and I'm.
Oh, I'm still muted. He didn't unmute me. What? Fine. But now you can unmute me. Instead of asking the room, you can ask me to stop, or you will mute me. Okay, but just like don't make it about you. Okay. Oh my god.
I get that you're looking for a moral high ground that you're not going to find.
Yes.
But that's because my outlook is highly informed and very consistent. And you know, I don't think you're used to that.
I mean, I think at the end of the day, like what I've tried to tell them is that the whole like the level of the end result of anti-Semitism or like philosophies like that ends up being self-destructive to the nation.
Wait, did you say anti-Semitism?
Mm-hmm.
Wait, what are we talking about? The ether?
Well, we were talking about the influence of anti-Semitism on non-acceptance of um, Einstein and some of the other theorists, which I think there's a relationship between, just from what I've seen.
Oh, for sure.
We don't have to continue that. We don't have to continue that topic anymore, I guess. But it's just an observation that I had, and then we were having a conversation.
Yeah, I agree for sure. Yeah, I've seen it. Yeah, I mean the whole conspiracy world seems to flow to, you know, to tribalism. It's tribalistic in its nature. So
Definitely. Well, and I just think those attitudes end up being self-defeating. Like I think they see it as a sign of strength, but it's really a sign of weakness in my view.
wait, you think wait, because you don't want to say you don't want to call people by their names. Are you trying to obfuscate the conversation? Because I'm not going to be able to follow. So let's give them titles.
No, I'm just saying in general, like racism, anti-Semitism, philosophies, if you will say it like that, I think are self-defeating and ultimately a sign of weakness. That's what I would argue. And if you look at like the historical record, I think that that's broadly supported.
I mean,
in the end, they end up being self-defeated. I mean, I understand having a national identity and things of that nature, like Japan does, for example. But like,
well,
so I mean,
Japan is as a country is pretty racist.
But they're also suffering for it now, right? Where their population has gotten to the point of saturation and there's no placement. So I mean, you know, it's causing issues now where they have a increasingly geriatric population because
yes,
they allow basically zero immigration from anywhere.
Yeah. I'm just saying they're not breaking the mold of nationalistic identities.
If that's what the people choose, if that's what it is a democracy. I'm not a Japan expert, but I'm assuming they're a modern democracy.
Yeah.
And they vote, so that's what they choose. Okay. Maybe the next generation will choose otherwise, but this is what they have chosen. This is democracy at work. Okay. We don't need to subvert their democracy. We don't need to subvert their mind and their thinking.
Who's subverting anything? I'm just providing.
No, I'm not saying no one someone's doing it. I'm just saying we don't need to do that. We don't need to do that. That's all. Thank you.
Yeah, I mean, I think that countries have a right of sovereignty and people have a right of democratic rule, but the reality is, that's a pretty funny one. The reality is just that, you know, I think that it ends up being self-defeating. I think that there's probably a realistic middle ground of nationalism where you get the best of both worlds. Yeah, that's my view anyway.
I keep hearing I don't know if it's a conspiracy theory, but I'm hearing something about this alleged crisis in Europe where they did the numbers and the amount. It has to do with the let's say like some population in Europe.
The replacement rate.
Yeah. You can say it for me.
Yeah,
go ahead.
I was pretty sure I knew what they said.
Yeah, basically that the whatever population is there, whatever those people are, is they're like being replaced in population by all whatever is immigrating there. So in this particular thing that I heard or read, it was about the incoming Muslim population and the vast disproportionate number of kids that they're having versus whatever the local thing is. So we could think of it as like Japanese or British or German or whatever, wherever. And they did the numbers and they're like, if it as it is, they're gonna be basically non-existent come 20, 50 years.
Well, yeah, the Muslims have destroyed their countries, so now they're nowhere to live, so they're going to live in Europe and probably going to turn Europe into the same thing.
So, not to say that that's a good. I mean, there's good things about it. So Japan is potentially avoiding that situation by focusing on Japanese people.
Yeah, they don't want the country to end up like the Middle East, where there's people.
Okay, so what y'all are promoting is like, so what y'all are talking about in the U.S. is called the Great Replacement Theory, and I find it deeply offensive and un-American. You can have your own values, but you know it's pretty darn.
Yeah, say some reasoning. We don't care about your feelings. We don't care about your feelings. Give us some reasoning. Give us some logic.
The reasoning, Dave, is because it is in fact bullshit. Okay.
I mean, demographic change is a real thing that happens.
Okay, I'm not interested in this emotional debate. I'm out. Thank you.
Yeah.
Yeah, you're too emotional for it, huh?
No, you're being.
I'll
just said it. You just appealed to emotions. I'm gonna
explain
theory. This is happening for a reason. It's because the West has desensitized or de-incentivized having the nuclear family. The only way you can have these children is if you're single, and if you are single having babies out of wedlock, then you get incentives. Or if you're immigrating, then you get free rent and all these things.
That's hilarious.
There isn't enough. There isn't a.
Do you remember
enough people having babies? It's not a hilarious.
Omni, are you old enough to remember the welfare queens under Ronald Reagan?
Yes. This line of bullshit is not factually supported. Facts, unfortunately, only care about my feelings because I'm tight with facts. But they don't care about your feelings, and that's all you got for your great replacement theory. You don't have facts. You have a broken ideology that colors your entire perception, and you've decided to believe.
You're getting all meta about it. There's no philosophy here.
I'm telling you
it's a simple fact that
you should listen to, but you
won't,
the
nations of the West aren't having enough babies. No, you're. It's not an ability thing. It's a thing. You're like trying to read somebody. Like you just called. I'm only stepping in because you're calling him racist for saying.
I can read you.
It's a simple logical thing.
I have a rare ability to read minds over TCP/IP.
Wait.
Infrastructure to keep the banks running.
Wait, hold on. Wait, what?
Can we take it just 10 seconds? Like, do we?
I'm not making
let me ask a question, please. Like, do we want to try to have a constructive discussion about demographics, or do we want to try to talk about something else, or racism, or like let's make
just like unfair
a simple thesis and discuss that.
Or something. Yeah, I'm just stepping in. It's kind of ridiculous. You don't need to get emotional about it.
Okay, so what's the?
It's not a bad thing or a good thing.
So,
no one even made a statement of it being bad or good.
So into the break, give us one sentence that you think is true that you want to talk about.
He's inviting.
You were having a good conversation.
He's inviting you.
I like this ether part. Ether and quantum discussion. That's been great.
Should we go back to 20th century physics?
Yeah, that would be better, maybe. This is awfully contentious.
It's a hard conversation to have.
Every conversation is hard to have. Every
Some are
conversation.
more charged than others. Here's a conversation that is not charged. What is your favorite breed of dog?
You're gonna get people will get emotional about anything, apparently. Yeah.
That's racist.
About dog breeds?
You know,
Yeah, that's
I'm
racist. You're choosing
Yeah.
one dog breed over another. That is so racist. I'm so offended.
No, some dog breeds are horrific and should not exist.
There you go.
That's my belief.
They
Okay,
are
yeah,
all
yeah.
good boys. Every last one of them.
Does
All
are you
dogs go to heaven.
Did you come over here from 24/7? I'm not. I don't like. I'm just curious because I think I remember you coming over then, but I don't know you.
Wait 1 second. Aeneas, you're writing good comments. Let me see. One thing that's important to remember for everyone is to stay humble because our ignorance will always far outweigh our knowledge. Let me give you a link to my Discord. If you want to come to my Discord and talk, that would be nice. I should always. I'm surprised I didn't paste a link. I always paste a link to my Discord. You can come to my Discord. We can talk. I also sent an invite to this guy, but he's not responding. Let me see what else you said. No comment. That's me. Okay. Yeah, but people get very emotional about topics. Everything scares everyone. Everybody's on edge right now. It's easy to say, yeah, we should all keep calm, but everybody's afraid that the world is about to blow up, and everybody's trying to, well, everybody's just trying to survive at this point. I appreciate that you try to keep things positive and not personal. Oh yeah, but that's always they always attack me personally. I'm not even familiar with your ideas at depth, but everyone should always have an opportunity to share. Yeah. Yeah. Well, if you go to my stream, so you can go here to the side chat and type something, I'll come over. Or type in general, I'll come over. But for now, I'll go back to their stream. Let's see what's going on.
Favorite map? Or what map do you think is most accurate?
I don't know, because the Mercator map is not accurate, apparently, or there's some conjecture over it, but that's the military map. That's what the military
Do you have a
uses.
car?
And that's the GPS map too.
It's no, it's not the
Which is
GPS map.
flat. Which is flat.
Do you have a car, Daz?
No, I don't drive.
Okay. Do you travel much or get out of the house much? Like, you've been on planes or trains?
Yeah, quite a lot.
Okay, so are you old enough, like, I don't know if they still do, but you used to be able to go to any gas station and they would just have a rack of maps, and you could pick up one of these maps and follow it, use it to like get anywhere you wanted to go, and it would tell you like how many miles it was or how kilometers, from one place to another. Are you familiar with that? You remember those?
Yeah, it was all flat too.
Yeah, they were. Well, they were folded up weird, and it seemed like you could never get them folded back.
So, I mean, I should write a paper how to resolve the double slit experiment using the Aether. That's a pretty good topic. Let's go to my server. Let's park our boat here. So we should write a paper. Did I write any paper about any double slit? Okay, unified. All right, we should write a paper how to resolve how to resolve any double slit. Any double slit experiment using what's the name? Aether model. All right. And Mirrorslave. September 25th, 24. Diagrams. Abstract. We'll come back to the abstract. I think more important is the diagrams. All right, another paper, another day, another paper. So this should be the name of the stream. What's the name of the stream? My Ether Theory. New paper. How to resolve any double-slit experiment using the Ether model. So we can begin the paper with the Ether model is a long forgotten of our physical universe. For some strange reason, modern physics lost its favor. It lost favor. For some reason, the Ether model lost its favor in the eyes of modern physics. It is a strange turn of events and should be studied by, I would say, economists, by scientists. Namely, why did such a powerful yet simple theory. Every time I say theory, Siri wakes up. Oh my god! Namely, why did such a powerful yet simple theory become such a, what's the word? Demoted? It's like when you say ether, you might as well say flat earth. Namely, why did such a powerful yet simple theory become such an anathema? That means extremely abhorrent. Why did it become so hated? That is the question. Why? But that's for another day. But that's for someone else to study. Today we will examine the ether theory as a model to try and explain one of modern physics most challenging and or ubiquitously there's no such word. Oh, almost ubiquitously. All right. Challenging experimental results, namely the double slit experiments. Okay, let me go close some windows. La 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 la. Give me a minute. Eine Minute. Give me eine Minute. I'll be back. I need to, I don't thank C-Line enough. Like, he gives me such a platform, and I take it for granted. I need to thank him. I need to take some time and thank him. It's not good that I'm not thanking him, because after all, I don't have any other place to express my opinions.
Buncompadre Peak, the basin of Buncompadre Meadow.
Where's this Tabato or yes, camera can work without a phone outage.
I'm telling you that I had GPS signal in this valley with a receiver that was not a phone in this valley.
Yeah, I don't believe you. Well, whatever.
You don't
Are you
believe
saying
him?
it came from? Are you saying it came from space?
Well, we'll
There
get
you
there,
go.
but
He just doesn't believe it.
Oh,
He doesn't believe GPS comes from space.
question.
That's
Does it
cope.
come from
This is
space?
the pure uncut copium that I come here for. Oh,
Right? Where else are you going to find this kind of denial?
If you see in chat, Dan put a map where it has all of the cell towers. So there's probably a lot of towers. They're just like, I don't know, behind the mountains.
No. The thing is, they need a direct line of sight to 3 towers for triangulation and trilateration. So,
Not anymore.
what do you mean not anymore?
Modern towers have directionality from the tower itself, as well as utilizing time of flight information.
So how many towers do you need to determine position?
One will get you pretty close with the 5G. It's really
Without-
impressive. Yeah, even with multipaths and stuff like that,
Hold on,
it's
hold on.
really
Is that
impressive.
altitude?
Say again?
Can you get altitude?
Probably, but I mean, assuming you're on the ground, that's known.
All right. Okay. So let's seal man it then. Like looking, I can map out where I was, but my point is there couldn't be direct line of sight to even one tower at any of these locations. And you can
definitely
verify
look
that
like you're at An Valley. And I did not see any electronics on any nearby hilltops. I was looking on Google Maps, but I just did the first one.
Yeah, and then the second one, I was here a few years ago, and I verified there's no signal there, and then I'm going to find another one. So
Also, yeah, if you were getting 5G signal, you'd be getting cell. So why do you get cell? Why do you get GPS but not cell signal?
theoretically, they could be different systems, so we have to allow that argument.
He is busy, but Obscure is already sleeping. Amber is sleeping. Chinas is already up. Spaghetti, I don't know. Alright, whatever. Okay, let's get back to writing our papel. Okay. So, namely the double slit experiments. In modern physics, we assume that vacuum of deep space is indeed empty. And nevertheless, we all agree that light demonstrates wave-like behavior. Yet we all look out of our windows and see far away stars. How could these stars light arrive at our eyes? If the light is a wave, so if light is a wave, then it must be waving through something. if indeed the vacuum of space is devoid of anything, then what is this wave waving through? If nothing, then that it contradicts logic. LOL. In this paper, we will assume that the universe is filled with, or therefore logic forces us to conclude that the void of space cannot be empty, that something must be there, that light waves through that something. That something used to be assumed, it used to be agreed by all, it used to be obvious to the ancients. That the light waves through that something. That something used to be and was called the ether. In this paper, we will assume that the universe is filled with this something. Yeah, but this has nothing to do with this paper. This is too much of an intro. This is an intro to an intro. In this paper, we will assume that the universe is filled with this something. Now let's talk about the double slit experiment. I mean, this is useless. This is absolutely useless. It's a good intro to an intro to an intro, but not an intro. This is a separate paper. What happened? What happened to the ether? Let's put it somewhere. What happened to the ether? So, what is this untitled document? Oh, that's today's document. So, all right. I think we have like an X. Wait, this is all in X? All these papers are in X? Well, we have dumping ground. Dumping ground is the most important one. That was the intro. Let's get back to the actual topic at hand. How to resolve any double slit experiment using the ether model. All right. The double slit experiment is a known unresolved problem in modern physics. Modern physics assumes that all elementary particles are, as their name suggests, particles. As particles, when we fire them through two slits, I should use the word two, through two slits, through a double slit, we expect them to behave like bullets. We expect them to create a double pattern on a detector. We are all very confused when they don't obey this prediction. Instead of a double pattern, they create a multitude of patterns. They behave as if they were waves. But for some bizarre reason, we keep on claiming that they are particles. This paper, we are going to give another model a chance. The other model of what elementary particles are is waves. But waves in what? In this paper, we will assume this is so obvious. I'm writing about the obvious of obvious. In this paper, we will assume that they are waves in the ether. Indeed, the ether was invented in order to allow light waves to propagate through space. We later discovered that light is an elementary particle called the photon. It's too long. But as we are now planning to do in this paper, we will redefine the photon as a wave, or more accurately, a quantized wave. It's a quantized wave, or a wave packet, but in no way will we analyze it as a particle. The same goes for the electron. We will analyze the electron as a wave. Did I say wave in the ether? As a wave. What is the photon waving in? It is waving in the ether. Just as light did, so too is the photon. It is waving in the ether. And the same goes for the electron. We will analyze the electron as a wave, as a quantized wave in the ether. We will see that as a wave, both the photon and the electron can easily go through two slits at the same time as they split into two waves. These two waves can now interfere with each other and create a constructive, a destructive interference, a constructive and destructive interference pattern. We will show that most of the paradox of the double slit experiment is resolved via the Aether model. We do agree that some of the double slit experiment paradox remains. But we will argue that the Aether model offers a simpler and better scientific explanation to all double slit phenomena. Okay, that's it. That's the intro. And that's the intro. Are you sure you want to switch?
They won't come back here if that they're unlikely to come back if they get dogpiled, basically. So for moderation's sake.
Yeah. We should be better at taking turns speaking.
Yeah, I mean it's fine. It's just
I thought it was friendly.
Is there a way to grab the mic and then, isn't there like a tool in Discord so that there's only one mic in the room and gets passed around somehow?
There were tools for that in Twitter Spaces that were a lot better than Discord. That was my experience as a mod.
Mm-hmm. Interesting.
Yeah, well, we're limited because we don't have the number of members and stuff, and we haven't converted over to community server, so we didn't get we didn't get
stage.
Oh, stage? It's called stage?
Yeah, we have a stage. Yeah.
So stage is in a stage. There's a single mic.
So stage, you can promote certain people to only have speaking roles, and they have permissions to. It's like a controlled environment where everyone can be in one channel listening, but only certain people are promoted to speak to the stage, which is pretty nice for events. We do have our debate channel that we use for that, which is our jerry-rigged solution because we don't have the status to convert over. But yeah.
No, I'm talking about something else. Like, I like the fact that anyone can say anything, anytime. It's like basically freedom, but I don't like it that two people can speak at the same time. It's better if I could click the button, either grab the mic or not grab it. And then whenever somebody grabs the mic, he has the mic. Let's say you can time out the mic after, I don't know, whatever timeout you want.
It could deliver an increasing voltage after 1 minute,
Exactly. No, what I would
they have to be more committed to hold on to it.
No, what I would say is the more pressure there is, the more people are trying to grab the mic away from you. So the shorter the timeout you get, like the less time you're allowed to hold on to the mic. So if there's a lot of pressure, so at times of pressure, the time gets divided into smaller pieces. So you can only say a few words, then everybody gets this, and then there's a line too. So anyway, I can think of so many ways to simplify the discussion so that
Damn it, where's D-Mock?
who's DMOC? Oh, anyway, I'm writing another paper because of our discussion, so I'm putting it in a paper. How to resolve any double slit experiment using the Aether model. So this is my intro. I wrote the abstract. It's in. I use the side chat, of course. I'm not.
Yeah.
I'm not a caveman.
I wonder if maybe he just kind of realized he wasn't going to be able to answer a lot of those questions.
Yeah, but
Sea Lion, you're obviously doing something else in the background.
I'm doing like 3 different things in the background.
Jesus.
He's talking to his real friends on the cool server.
I doubt it.
No, that's true. I don't have any friends. Except, people.
No, he's working, obviously.
But no, it should be working though. I'm gonna have to pull an all-nighter at this stage, but that's fine. It is what it is. So wait, yeah, I mean, I think that was the case, but also I think that we should just try not to overtalk people. I mean, it's just, I get everyone wants to jump in and then he's just saying shit that doesn't make sense, but it's like, if the reality is that if it's all Globers here all the time, the conversations are just going to get stale, and it's just not going to be an active server. I mean, that's just how it is. I mean, it's like, at least in voice, it's like, I don't know of any other server or whatever that if there's not someone on the opposing side of the argument, it kind of gets stale. That's my 2 cents. And I think that we've had, to the credit of the people in the server and everything, and credits myself, of course. Go me. We've had some really good conversations here that have been civil and like informative.
But that's just because I'm such a nice guy.
Oh, thank you.
That is part of it. I do enjoy talking with you, Mr. Slave.
Yeah, I mean, I try to be, on topic. I try not to ever make it personal.
So let me ask if we're ready for a topic here.
Mm-hmm.
I kind of went crazy and I ordered a bunch of magnets from Amazon. And I have magnet wire. I have test equipment, power supplies, etc. Like, does anyone want to propose an experiment or a project?
With magnets?
Just magnets. I mean, it's amazing how far physics got with magnets and wire. Probably I should have been born in the 18th century, but
I was thinking to do a Stern-Gerlach experiment.
I saw that. Yeah.
What do you mean you saw that?
Well, that was discussed. That came up in the debate, and I pulled up the Wikipedia page and was reading a bit about that. Yeah.
I mean, it's not Wikipedia is probably not going to explain to you the depth of this topic. I mean, the question.
I don't want the depth. I just want a basic intro to get my head around it.
I have a presentation. Do you want an introduction to it? That slide's handy right now.
Sure.
1 sec.
Potato, yes, I have ordered magnets from them. They are awesome. But I was kind of clicking on Amazon discount sales on Amazon.
Yeah, man.
Wait, but C-Line, I sent you a question. You were supposed to help me understand something.
Oh, was I?
Yeah, you said like anyway. Look, I'll find it. Let me show you this thing. Forward. Can I forward it to the room? Okay. Yeah, I guess I can forward it to the room. No, I'm gonna copy it. Can I copy it? Copy image. I don't have any other choice. I'm gonna put it in the side chat because I'm not a cannibal. So this thing, I mean, this is where I don't understand. I have a friend and he says it's really simple, but Marsh, do you understand what I put in the side chat?
1 sec.
Anyway. Wait, are you having a private discussion about the Stern Gerlach?
No, but I did post in the live stream chat. Okay, so where
I pasted it
what
in
did you post in?
the side chat where I post everything.
Summerfield 1916?
Summerfeld. Summerfeld or Summerfield?
Sorry, it's a little small on my screen.
I'm sorry. Yeah, you can click on it. It will. Oh, you're using your iPhone?
No.
Summerfeld 1916.
Okay, so what am I looking at?
Let me give you the link to the video if you can. But
I'm not going to watch it.
I know. Okay.
Can you give me
Sure.
Can you just tell me what it is?
Summerfeld took Bohr's model. Right? So Stern and Gerlach, they said, let's disprove Bohr's nonsense. This is a famous quote. Stern, Gerlach,
So Bohr developed the model with the electron orbitals around the atom, right?
I got my presentation. Here's something I prepared earlier.
All right.
But you're correct, more or less, yeah.
Well, Mr. Slade has it boiled down to 3 integers, so.
But that's Summerfeld. So I don't.
You see my screen?
Yeah, we see your screen.
So yeah, what they said is originally was Stern said if this nonsense of Bohr should in the end prove to be right, we will quit physics.
What?
There's the beautiful.
But can you explain
drawings of?
Wait, so can you explain Bohr's drawings and what they meant by that? Like it's like they're talking.
Yeah, so the earliest model was the so-called plum pudding model.
Mm-hmm. Okay. Yeah. Are you there?
Yeah, I'm here. Do you hear me?
Yeah. Yeah. Go on. Can you hear me?
So the Thomson plum pudding model,
Mm-hmm.
which was sort of just like an amorphous unified atom with like a sea of particles.
Mm-hmm.
And Bohr is just described instead discrete orbitals that would be quantized, meaning that they could only take certain states.
Wait,
so you see here how each state builds off the prior state.
I don't understand these drawings. I mean, So from what I understand, Bohr gave us the orbits.
Yes, but
And
he also believed that the spatial orientations were quantized.
what year were
Well, like
the
crystals would be an obvious example, right?
Yeah.
wait? What year are we? What year did he draw this?
This was from his Nobel lecture, I believe.
Maybe in his Nobel he was. That's already post de Broglie, because de Broglie explained Bohr's model. Like, so that I don't think it's.
Here's the original source.
This looks like he's already influenced by Schrodinger. This is like he's basically saying Schrodinger. This is Schrodinger, isn't it? Like it's
No.
like
I think Schrodinger's decades later.
Wrong one. I almost just shared furry porn on the stream. That would have been bad.
I wouldn't know that it's.
Folder.
I wouldn't know that it's
I have a whole
porn.
folder of. I have a whole folder of.
Furries?
Yeah. So what were these? I have a whole folder of Globe Science furry porn.
Amazing.
Yeah, it's pretty good. You should see the one of Cavendish.
Nice.
No, I'm kidding. I don't actually have that.
Isn't no? Tell me it's two big balls.
Okay.
I made it sound convincing though.
Anyway, okay. The hydrogen has one circle. That I understand. That would make sense according to Bohr. I would expect to see multiple circles, but instead, nothing here is something I would predict Bohr would draw from the
How many
Bohr.
electrons does hydrogen have?
Hydrogen 1.
So why would there be multiple circles?
Because the idea is that every electron that hits it, the electron can go up in orbit or multiple orbits and then drop down. And as it drops down, it ejects a photon. And that's how you get the spectral lines of each element of hydrogen. Like each element has its own spectral lines because it has
Maybe Bohr drew these before they had the different energy levels figured out.
Yeah, I'm not sure, but you can see they're labeled, right?
But even if it is kicked up a level, you still only have one point. So it's kind of hard to, it requires. What does it take to define an angle?
What angle? No. So in the
have something. So you're just going to get a circle if it's just one point. It's just a question of radius.
So the original Bohr's model is that there's n equals 1, n equals 2. There's different orbits, and each one they're just multiples of h of Planck's constant. So the first orbital, the first whatever orbit is 1h. That's the angular momentum. It happens to be that h is an angular momentum. That is the dimensional analysis of it. And 2h is the next angular momentum, and so on.
Okay, but when there's only one electron, it's only going to look like a spherical shell.
No, according to Bohr, it's still planetary. Bohr was still thinking about planets. De Broglie.
Okay, fine, but it's still going to look like one orbit, a circle.
Yeah, but if it is hit by a photon, if it absorbs a photon, then it Exactly. It can go up to 2. The angular momentum goes to 2h and 3h and 4, depending on the amount of energy it absorbs. Different frequencies and such, different energies. So high energy photon can kick it maybe even all the way out of the of the atom, and then we say that's the ionization energy. The photon had ionizing energy. It turned the hydrogen into an ion. It's a positive ion.
Well, this drawing's a little more primitive because it doesn't have the different energy levels. It says there's one electron. It could be at a different orbital level, but then it would just be one. And then if it drops down, it'd still be one.
I mean, I don't you.
Hey, I'm pretty sure these are Bohr's original drawings, but
that is very. I mean, every time somebody teaches Bohr, they always show just circles within circles. That is the Bohr's model. So
okay, let's talk about something with more than one electron.
I have radium here.
I don't think. I mean, Bohr analyzed the hydrogen and the helium when he had no choice. I don't think maybe he analyzed other ones. I mean, they're very difficult to analyze.
Wasn't he a chemist?
Bohr actually had a friend who taught him chemistry. Yeah, and they say that I saw a video. They said, yeah, because he had background in chemistry, it helped him figure things out. But he himself, Bohr, was a physicist.
Can we know Bohr's concept was limited?
For sure.
Let me find the Stern-Gerlach. This is a really great paper that goes over the history. But let's see, what does it say? Let me find I can find my, oops, don't want to show my code. Don't want to impromptu code review here.
What language is it?
Python.
Uh-oh.
Okay. So let's see.
Have you checked your math library lately?
What's wrong with the math library?
Well, it's like the sine and the cosine functions.
Yeah, he uses sine and cosine all the time when he does AI. It's like very useful.
They are very useful, actually. Use them for Fourier analysis.
Why would you do Fourier analysis?
For time series?
You'd have to teach me what.
Is that part of statistics now?
Functional statistics, yes. Functional data analysis uses Fourier series to analyze a time series.
Anyway, you can have another presentation. I'd love to listen to that. So, what's this particle beam experimentation?
Here we go. Okay. So in 1921, I just needed to go to the source because it was more detailed than my presentation, and I didn't remember the details. In 1921, the most advanced quantum theory was still the Bohr model, as generalized for a hydrogenic atom in 1916 by Arnold Sommerfeld and Peter Debye. Their proposed quantization conditions implied that Bohr's quasi-planetary electron orbits, this is the key, should assume only discrete spatial orientations with respect to an external field.
You're not showing us anything.
However,
you know that, right?
What?
You're not showing us anything. You're
not looking at my screen?
Particle beam experimentation? Where are you reading from?
Dude, why is this not? Oh, am I just sharing the presentation? I thought I was sharing my whole screen. I'm sorry.
Oh.
Don't share anything that's gonna give me nightmares.
Oh, I could if I wanted to. Believe me. Just off YouTube, actually, that I could find something. But just neither here nor there. Okay, here we go.
Mm-hmm.
So this is related to the Zeeman effect.
What's that?
Shown here. The Zeeman effect is the anomalous splitting of spectral lines due to the application of a magnetic field.
What are we looking at?
I hate it when that happens.
What is this? Yeah. What are we looking at? Spectral lines?
These are the spectral lines of Mercury.
Why is it?
If you're seeing that when you wake up in the morning, you know you're having a bad day.
Wait. Okay.
Well, there's this really funny quote about Wolfgang Pauli, and the anomalous type was hardly understandable since very general assumptions concerning the electron using classical theory as well as quantum theory always led to the same triplet. A colleague who met me strolling rather aimlessly in the beautiful streets of Copenhagen said to me in a friendly manner, "You look very unhappy," whereupon I answered fiercely, "How can one look happy when he is thinking of the anomalous Zeeman effect?"
I can relate to that.
So the anomalous Zeeman effect, what is that? What is
That is just exactly what this is. It's a
Bring up the
basically,
picture again.
yeah. This is from Wikipedia, but
so A is
Okay, what's A?
without magnetic field, B with magnetic field, C with magnetic field, split as longitudinal Zeeman effect.
So there are
B,
two Zeeman effects.
well, B says with magnetic field, spectral lines split as transverse Zeeman effect. So B and C is transverse and longitudinal Zeeman. That's B and C. A is without. Okay.
Transverse and longitudinal to what? The polarization of the light, maybe?
Well, the spectral lines of mercury vapor lamp at wavelength 546.1 nanometer showing anomalous. What's anomalous? I guess. Oh,
Out of place.
yeah.
no. I
Let's pull
know.
up the,
I know what anomalous mean. I'm saying what is anomalous about this image? Like, what is nominal? What is anominal? What anomalous? What is?
The way the lines split due to the magnetic field.
But what? So because of the so they did not expect anything to happen with a magnetic field, so they were surprised that a magnetic field had any impact, I guess. So there
Or
is
that, or they were laying awake at night trying to figure out why.
so the Zeeman effect is always anomalous, I'm assuming. There is no anomalous and anomalous. There is
I think
only
it's not anomalous now that we know how to explain
there
it.
is.
we know.
There is. There's two.
Oh, there is anomalous. Oh, normal. Normal is anomalous. Okay.
Yeah, there's two.
So he had a normal Zeeman effect. One
You can
distinguishes
see it
between.
in the.
Incredulity is not an argument, guys.
Wow,
Yeah.
what's going on? So
Apparently, this is the Zeeman effect in the sun.
what's rotating?
Fuck if I know.
CGI.
Polarization. And
I have
what's
no idea. It's really cool, but I don't know what it is.
what are the slinkies coming off of it? Why is one?
Light?
Circularly polarized photons, perhaps?
Perhaps, yeah.
Why?
I don't
Why
know what
is
those are representing.
maybe one is blue
Why
and one
one
is
spinning
red?
fast and one is spinning
Circular.
I don't know. That's not really. It's not really
Anyway,
self-explanatory.
this is a major rabbit hole. Major rabbit hole. Like
Yeah.
this is
The
Anyway.
inverse Zeeman effect. Oh, gosh.
the reverse.
But okay, basically, all you need to know is that the Bohr model was adapted to have discrete spatial orientations of electrons relative to an external field.
Well, that's already Sommerfeld, isn't it?
No, this was Debye. Oh yeah, no, it's Sommerfeld. Yeah.
What's an external field?
Just like the application of a magnetic field.
I'm trolling. Sorry.
No, it's okay.
Like I was telling Mr. Slave, a field is a thing that where you have a value at every point in space.
Yeah, he's Celine is a mathematician. Like he can teach us about fields.
But the word is used to mean different things.
Look, Sommerfeld. Sommerfeld was amazing. I mean, I saw the video about how Sommerfeld expanded Bohr's model. I mean, Sommerfeld, he injected Einstein's special relativity and elliptical orbits, both, and made predictions, and they were accurate. It's like you sit there, your jaw drops.
Look at these fucking chads.
Yeah, I mean, unbelievable. It's like shot in the dark, blindfolded. After you spin the guy 20,000 times and he hits it on the nose first time. It's like unbelievable, beyond belief, and it's understandable. But then,
Hey, imagine being an ambitious physicist in 1905.
yeah.
I know. Yeah. Okay, so basically there was a bunch of work they were trying to account for the magnetic moments based on quantized levels of the electron orbits.
Wait.
And that gave Stern the idea. Stern? Yes, Stern was the originator.
So,
Who recognized, according to the Bohr model, the space quantization should be only twofold, as the projection of the orbital angular momentum was and in case you wonder why we're talking about orbital angular momentum, the model that we use, the Bohr magneton model, assumes that there's a current ring, and in atoms with a non-zero magnetic moment, there's what, like the different like magnetic types, what paramagnetic, diamagnetic, whatever the fuck.
Ferromagnetic.
right, but I think Stern and Gerlach they kept referencing Bohr, but it's actually Sommerfeld, and that's the image I have in the side chat. So Sommerfeld came up with the fact that the angular momentum itself should be quantized. It should be a multiple of Planck's constant. So the directionality of the electron orbit, like Bohr was thinking in a planar. Bohr had the Keplerian model, like literally planetary model, that in a flat space, in a flat plane, all the planets are orbiting in one plane around the sun, and that's the way he envisioned.
I don't think he did.
Yeah. That Sommerfeld said, let's go to 3 dimensions. After Sommerfeld did the ellipse and the Einstein special relativity, then he added also, let's go to 3 dimensions, and he added phi and theta. So yeah, that's exactly it. That's the M. Anyway, it's supposed to be spherical coordinates instead of just orbital or whatever.
Right, but basically what Stern recognized was that it couldn't actually attain every value. It would only have a twofold quantization between plus or minus h over 2 pi, which meant that magnetic deflection. So the next thing you need to understand is the splitting force. So there's the Lorentz force, which is given by Q times E plus V cross V. Q times the quantity of E plus V cross V, where E is the electric field, and let me pull it up. So this is the usual. There it is, right there. Yeah. So F, and this is how we know gravity can't possibly be electromagnetic, because neutrons have Q equals 0, but still experience a force that is a net force.
Now we know.
Among other ways.
Yeah, but that's my favorite one because there's no way around it.
That's good.
The only recourse is to pretend that neutrons don't exist. So, which is an untenable argument, but
it's CGI.
CGI. Q times E plus V cross V, right? Well,
so the electron is
the velocity
right.
Of the particle.
So the electron is rotating. Right. So the electron is rotating, is orbiting at a v velocity in a b magnetic field. So we're getting
I think
the cross.
If it was an orbital velocity, you'd look at the tangential velocity to calculate the Lorentz force.
Yeah, because
1,000 miles an hour.
Because at this point, there's no they didn't know about spin, so they were looking only at orbital. So and then you have Q times Q times V or something, whatever. Q times E. Okay, So, but why are you talking about the Lorentz force?
Because I want to differentiate it from the splitting force, which can affect anything with a magnetic moment. So the splitting force, let me pull up my quantum notes 1 second.
So the moment is what? Where the center of the
moment
charge differs from the center of mass, maybe?
So you will have a non-zero magnetic moment according to the Bohr magneton theory. If there exists, let me try to find it.
So, meanwhile, while you're looking, I'll try and explain. So, if you see in the diagram M, the vector M, and let's say the B points up.
Well, this is a fun one. Sorry, this I don't know why this got pulled up, but little short Stephen King poem.
Nice. So if B points up and M is off center, so right, M wants to be aligned with B. So if B points up and M doesn't point up, right, just like a compass.
M, we say wants to be aligned, but do you maybe mean that there's energy stored in misalignment?
Yeah. Once, right, it's like it's a loaded spring basically. So there's a force. So
but moment I think of as something being offset from center of mass.
Yeah, like a compass, right? You put a compass.
It's like a angular force.
Yes, you put a compass in a magnetic field, it rotates. That's exactly it. So the electron, the magnetic moment, the electron spinning, the magnetic moment.
Oh, okay, no. Yeah, magnetic moment, also known as magnetic dipole moment, is the measure of an object's tendency to align with a magnetic field.
Perfect.
Which is a vector quantity.
See, if you have a button magnet on your refrigerator, you would just say this magnet has a magnetic field.
Sure.
Right, but what happens is in a ferromagnetic material like that, all of the atoms have a
spin,
magnetism, a magnetic moment, and then magnetic moments align to create a larger ferromagnetic, basically an aligned magnetic field of the entire material.
Right.
I had where was it in there that I found?
And
how is it different?
It's not. Ferromagnets internally are just little electrons spinning around the orbit. It's just that they're all aligned. But you cool them down, right? You heat up the iron, and then you cool it down while it's under a magnetic field. So all the electrons and all the atoms are aligned, and then it cools down as a magnet.
Yeah. Basically. And let's see.
But why do they call it a moment when it's in a atom?
I don't know.
Because it's
basically
it's orbiting.
If you have a material that reacts to a magnetic field without being charged, so a silver atom reacts in this fashion because there is a single unpaired electron in the outer orbital, and this isn't quite how it works in reality, but the way we model it is by imagining that electron is orbiting around, right? And it's unpaired in an outer orbital by itself, which is effectively creating a current ring. And we use the formula for a current ring to derive the magnetic moment.
Does your imagination have a citation?
Yeah, I do actually. The Feynman lectures.
What's the unit here?
Quantum mechanics, a paradigm approach. What's the unit?
Of a magnetic moment?
I don't know.
I feel like I should know this, but I'm not disputing any of this. I'm just trying to get grounded again.
It's just
old stuff.
It should just be like the unit of a magnetic field. Like, what is it? A Gauss?
Let's find out. It might not be, right? I mean,
Oh, is there more than one unit used to describe magnetic fields and their effects on matter?
It's an amp meter squared. Joule Tesla.
Oh, Tesla. Yeah, Tesla.
Joule times Tesla?
No, divided by Tesla. It's a joule over Tesla, I think.
Amp
Joules per Tesla.
Joules per Tesla.
That makes sense. Okay.
Why does it make sense?
So it's how much energy that it takes to produce a certain magnetic field. Field strength.
Let me see. In the definition of current loop, the magnetic moment is the product of the current. It's I. Okay, it's I times A. So A is what is? Oh, A is the area. What it's and I is the current times area. What? Current times area. Magnetic moment is current times area. Oh yeah, that's what it says. Current time. Okay, okay.
But then we break that down. We have a elementary charge divided. Okay, so that's Coulomb's law, right?
Well, the I is the current. So
hold on, let me find my.
No, I can explain it. Current.
Okay, go for it.
Current is defined as charge per time, and time is distance over velocity. And you multiply by the area, which is pi r squared. So it's charge over 2 pi r divided by v. That's the time. 2 pi r is the length of the travel of a single circle divided by v. Distance divided by speed is time. So q over t. That's I, right? The current is the amount of charge over time. Charge per time. So Q is the charge of an electron, and 2 pi r over V is the time of a single loop. And then you have times pi r squared. Is everybody following?
It reminds me of like Newton saying the area swept by an orbit, the unit of time is equal. Right?
No. It's just distance over speed, right?
You didn't even think about what I said for half a second.
I did. You mentioned Kepler's law. You're misattributing it to Newton. What do you mean? No. Look, this is just
Kepler
charge.
Orbits were circular. Although you're right, that does make more sense here. But
look, this is just charge.
I'm saying when you were talking about this, it seemed like you were skipping a step of integrating over the angle swept.
No, I times A. On the right side, you have A. A is pi r squared. Okay, so we're done with A. Now I is Q over T. So here you have Q. So the bottom is just T. Now, what is T? So distance over time is velocity, or distance over velocity is time. The denominator is just distance over velocity. The distance is 2 pi r. And the velocity.
Circumference, yeah.
Yeah, circumference. I'm sorry, I didn't know the word, yeah. So it's just Q over T times pi r squared. I can explain it again, right? So it's I times
I got it. I'm good, thanks.
Okay. And then the next line, so it's QRV over 2 because the pi's cancel out. One of the r's cancels out and v comes upstairs. So it's QRV. And then it becomes Q over 2m. Where did m come from?
Where did m come from?
Where did L come from?
L. Oh,
is that inductance?
I gotta find my notes.
No. L is MVR. L is MVR. All right. No. I can explain it. Let me try. Isn't L just MVR? So
hold on.
It's just he puts an L at the top, so he needs to add an M at the bottom to cancel out the MVR. He just threw in the L because it's nice to have an L.
Oh God, I don't want to dox my professor once.
Oh yeah, not that. We didn't see anything.
He's probably a NASA shill.
Okay, here we go. You missed a good game of play the towers or play where are the towers right here? Or did you see that? Who was just in the chat in the peanut gallery?
Not me.
I don't know everyone's voices.
Yeah, no, that was beautiful work.
Is there an L here?
Oh, okay. You multiply by M over M.
Yeah.
Yeah.
And then you get MVR is L, and then yeah.
Yep.
Mm-hmm.
Yep. There you go. Beautiful.
Mm-hmm. Yeah, I've been doing this around the clock.
Your suspension. Very impressive work, Mr. Prime.
Oh.
Okay, but how does this? Right. So Sommerfeld said that the changing of the magnetic moment can only be in multiples of n times h, Planck's constant integral multiples. What does that
I
mean?
recently viewed a very magnetic, attractive video on Pornhub.
You missed my joke about having globe Earth furry porn on the computer. And I said I had a good one of Cavendish.
Why am I not surprised?
Actually, I thought about doing a drag queen globe Earth science hour, and my name would be Lady Cavendish.
Wait, you dress
that would trigger it.
You dress as what do you call it?
No, I haven't done drag before, but I think it would be funny as fuck to do it just to like trigger people.
Awesome.
And also teach science.
That yeah.
Mr. Slave, he would look just like your profile picture.
I doubt it.
Exactly.
I doubt it.
Black hair.
I doubt it. My profile. No, my profile picture
I
is.
think drag queens have enough to deal with already without getting mixed up with flat Earth. That's just like.
Oh, that's true. That's fair. Yeah. All right. Okay. So can we move on from the magnetic moment?
Just, I would like to understand. So, what did Stern and Gerlach understand? What were they trying to prove? What were they thinking?
Well, yeah. So now that we've discussed the magnetic moment,
that's not Stern. Who is that? Is that Sommerfeld?
That's Gerlach. This is Stern.
Okay. Yeah, Stern I recognize. Yeah.
But
they weren't physicists, by the way.
They chemists?
That's quite the citation.
Oh yeah, dude. Oh, you think that's a good citation? Look at this one.
How can you say he's not a physicist?
I remember watching a video when they weren't. I mean, they probably, obviously, they knew much more than I know. I don't know anything, but their title was something else. I think physical chemist or something.
Yeah. Like,
look at those squiggly lines inside of that circle.
This is closed loop Feynman diagrams for the 0 point vacuum energy.
Awesome.
Which creates,
oh my gosh.
Which creates a pressure when you place steel plates or any sort of metallic plates in a vacuum. Or
does it require a container?
Oh, you mean the
bucket?
Is it nothing?
You could actually put this in a bucket, probably. I don't know. Would the bucket insulate it so that it doesn't.
No, it's quantum.
You know, you need stronger light mechanical waves, silly.
Would you have a
Yeah.
camera inside the bucket?
Do you have
We
like
need that.
cinematic equivalents?
This is one I should have harped on more in the debate because Alan had no explanation for it.
I
So
think
guess
you should talk like that in your next debate.
well, the next debate is supposed to be against Shade, so I might actually do it.
You have a citation for that, Shane?
Did you debate him again? Did you debate him again?
No, I debated Alan.
Oh.
Wait,
Yeah, hold on.
Sounds like shade requires sunshine.
wait, Sea-Lion, is Alan legit? Does he know physics?
No, he's not.
He's faking.
Well,
he's faking
he
it.
knows- He has like a weird view on it. He doesn't know how to do any of the math, admittedly, and he's good at like finding random obscure sources and stringing them together into a coherent narrative. It's just not generally correct or made or accepted. But it is actually he's good in the sense that he'll create this narrative that you have to like counter, right? And that gives him like this, and the reality is that none of the like lower level baby flirfs have any clue what he's saying. And I know that because I've never been able to get one of them to explain it to me. Like if you ask them to explain Alan or Shane or Witsit, they just get mad and either they run away, they block you, they accuse you of being bad faith or sea lioning, or I've never actually had one try to explain it.
I can do W2PL equals 4WE squared N divided by M. Come on, everybody knows that.
Yeah.
Anyway, so what did Stern and Gerlach try to prove?
They were trying to show that the space quantization would be limited of the orbital angular momentum, which we just talked about, which is how we derive the magnetic moment. They were trying to show that L should only have the values of plus or minus h over 2 pi.
The conversation was entertaining for about 5 minutes.
Which conversation?
And then we went back to boring science shit.
Oh, man.
You should have been here earlier. Hard. It makes no sense.
I'm just teasing, dude. I'm just teasing. Go ahead.
We had a 24/7 flat earther in here, and we were playing Find the Towers. That was more entertaining, but he left.
Find the towers.
Yeah, whenever a flat earther says towers are the source of GPS, I play Find the Towers with them. And, they never succeed. It's just
That sounds like a lot of fun.
Sea-Lion, I cannot understand. Okay, if you have fun, fine, but like you waste your life. I'm sorry, but like
yes, that's true, but we wouldn't all be here if it wasn't for that.
Yeah.
We all got here a certain way.
Hey, why does your username say I won't pay you if I lose a debate a bet? Why does it say that?
Because I had a debate. I had a bet and I didn't pay yet, but I intend to pay. As soon as I win the Nobel Prize, I'll pay. So,
How much money was your bet?
£1,000 and $100.
In a bucket?
No. What was it about? It was about my ability.
Spinning?
I had to come back in 20 minutes and derive the bending of light from Eddington using only Newton's law of gravitational and second law of motion. and I almost did it. It took me half an hour. I used ChatGPT, and I was off by a factor of 2. So I lost.
ChatGPT, they're not going to help you.
Well, it did. It just was off by a factor of 2. I told ChatGPT to pretend an asteroid is incoming at a star and get deflected. So it's the same equation. An asteroid gets deflected the same as light, only off by a factor of 2 because of relativistic effects or something. I don't even know why, but fine.
But, well, even if you were close, wouldn't that be good enough?
I was half an hour. I was 10 minutes too late, and but off by a factor of 2. So that's losing. That's fair is fair. But I didn't say when I'll pay. So
Yeah, but in science, we have
here.
measurements that have been proven to be inaccurate by a small margin, but we still count those measurements as accurate. So
it's fine. Look,
why
I
were you
lost because I'm off by a factor of 2, and I said 20 minutes, and it took me half an hour. So there you go. Look, I lost. It's fine.
Yeah, that's fair.
And I intend to pay as soon as I win my Nobel Prize, which should be coming soon.
No, I'm trying to be on your side, so you don't have to pay.
No, it's fine. It's fine. I lost. It's fine. I thought I could do it. I didn't do it. I lost. I'm happy. I discovered that I thought that you can derive it without the factor of 2, but then I realized there is a factor of 2, which is amazing. It cost me 1,000.
So what have you learnt for next time if you're going to get into a bet situation?
Do the same, because I don't mind losing as long as I don't intend to pay.
Because he's not paying, so
I am paying. I didn't say when.
How long ago did this happen? Just curious.
I think about a month ago by now or something. Maybe 2 weeks ago. I don't remember.
Yeah, it's been nearly a month. Yeah.
Yeah.
But
Nevertheless,
you don't do these things. You don't do these things willy-nilly to make bets.
I'll tell you the truth. So on this server, everyone mocks me and never takes me seriously. So suddenly people took me seriously when I offered a bet. So I was happy to get...
Funny how that works, isn't it?
Yeah, I was happy to get any attention, any serious attention that's not, personal. So I took it and I enjoyed the interaction. So it was worth.
Well, when you use ducks in your analogy, in your theses, we don't take you seriously.
I know that.
What's wrong with ducks?
I award you points for telling that story with honesty.
Yeah, I'm always honest. I'm always transparent. I never lie.
Yeah.
But the rubber duckies,
The person that says they never lie.
The rubber ducky.
You know how that comes
But the
across?
rubber ducky has a reason. It's supposed to be.
Okay, no, stop. We're going back to Stern Gerlach. We're not talking about the fucking rubber ducky.
Okay.
All right. So we've said so far that the magnetic moment is proportional to the orbital angular momentum.
Mm-hmm.
And Stern realized, based on the work of others, that the orbital angular momentum should be limited to plus or minus h over 2 pi. Thus, by employing a splitting field, which is an inhomogeneous magnetic field producing a splitting force, which we'll talk about in a second,
Okay.
there would be a deflection of, because of precession, there would be, because of precession and the orbital angular momentum, there would be a splitting into 2 states corresponding to the orbital angular momentum states.
Wait, why do you say precession?
This is why I got to try to find my notes.
No, but there's a problem with precession because we're in quantum mechanics. The angular momentum can only change in multiples of h. That is Sommerfeld's revelation when he went into 3D.
Yeah, well, this is how it was explained to me in the quantum class that I was in.
I guess you can have precession as long as it's in multiples of h.
Yeah.
It's probably quantized too, but it seems like precession could be where it puts a little bit of that extra energy if it can't fit it into a quantum
It
of
looks like somebody
magnetic
doodled
moment.
all over this work you've got your show.
Yeah, these are the lecture notes from my first week of quantum mechanics.
Did you pass?
No, I didn't end up enrolling.
Oh. So this is precession?
Yep.
Say that these bar magnets are moving with an initial speed v to the right. Oh, they're moving to the right. Describe the motion of the bar
The
magnets.
orbital angular momentum in a similar way that when you have a gyroscope that is spun up with a certain angular momentum and it has a resistance to movement, if you then move that gyroscope, it will precession will occur due to its resistance to the movement, and that's the same principle roughly that applies in Stern-Gerlach. So as you move through an inhomogeneous magnetic field, there is a splitting force. The splitting force is only caught. It has a. You notice it has to be an inhomogeneous field because there has to be a gradient.
Mhm.
And in a homogeneous magnetic field, the gradient is 0.
Mhm.
And I guess the Z field is the easiest way to create this experiment. But basically, what you have is the magnetic moment multiplied by the gradient of the field will create a splitting force. Well, if the gradient is only in one direction, the Z direction, if the magnetic moment was not quantized, then there would be a continuous distribution of the precessed bar magnet atoms as they come out of here, and they wouldn't. So the classical prediction is roughly speaking, it's this line here, or it's actually this.
But you know, I heard that the way it was designed, if you do the calculations, there wasn't enough time for the atoms to change their angular momentum. They couldn't precess. There was not enough time for them to even precess. That's what I
I think
understood.
precession maintains angular momentum, but it is a force that changes the direction.
I don't know.
It changed. The energy in the momentum is conserved.
Yeah.
But the direction, the vector.
No, so in this system, it's difficult to say. I mean, the system conserves energy, but the question is, does the atom conserve its energy, or does it lose energy, or does it gain energy? The system.
No one's talked about photons yet.
No. The system. I mean, the system conserves energy. The universe conserves energy, but I don't know if every atom going through is conserving energy. That's one thing I don't know. I don't know if they precess. From what I understood, they don't. They just go either up or down based on their angle. And the fact that they only went all the way up and all the way down, that's, I don't know. There's too
An
many.
oversimplification, probably.
I don't know so much about this experiment after weeks and weeks of diving into it that I don't know anymore. Like
Can we try like talking, like listening more and talking less?
Me?
I mean, that's how I'm trying to understand it, is trying to think about it and read it and listen.
Sure.
So this is the classical expectation. There would be a continuous. The splitting force would split the beam, and there would be a continuous distribution.
Okay.
Okay, so this is accumulated over multiple particles.
Yes.
Continuous beam.
Right. Assuming there is, right, every atom coming in has a different mu, has a different angular and magnetic moment in different directions, whichsoever. And spherical coordinates, 360 in every plane, completely random. So it should be distributed vertically. I agree. And the fact that it was split into up and down, complete up and complete.
This is the classical explanation, and this is what was observed, and this is the result. This should not have a hole in the middle.
On the plaque with the Nobel Prize, those are rotated 90 degrees. Just so
Yeah,
you know.
yeah.
Oh, they are.
It's up. It should be up and
this
down.
Is the other thing that I used in my presentation, I showed this image. This is look at how tiny this is.
A millimeter? That's not small.
Well,
What do you mean that's not small? It's less than a millimeter.
Not by like metrology standards.
You shut up with your weather. I'm not talking about weather right now. Oh shoot!
It's like hail.
But the question is, so
this is the sacred vagina of quantum mechanics.
Awesome.
What's up, Rudolph? I get you confused though with Daza and eggshells. I don't know why, but you sound it's the Aussie accent. When I don't see who it is, sometimes I get confused.
I haven't listened to the debate yet, but I will.
Okay, it was a lot of Alan just wildly coming up with random shit from 80 years ago, and Stone apparently did some math.
Wait, does Alan understand GR? Does he know stress tensors and tensors?
No, he doesn't.
Hmm.
No.
Mm-hmm. Anyway, so you're saying that it should have been distributed, and it wasn't, so it's weird. Okay, I agree.
Yeah. This is so what he found. This is completely consistent with the expectation of a quantized orbital angular momentum.
What does that mean?
Because, well, it means that the orbital angular momentum can only take two states, h or h over 2 pi or minus h over 2 pi. It can't take a continuous value, which means that the splitting force, this is fixed. It's a property of the field.
Sure.
Right?
Yeah.
This, in the classical, there's no reason for this to be quantized. Meaning only taking discrete states.
But it has a direction. It's a vector in 360 spherical coordinate space.
Correct. But it's nonetheless, its magnitude, let's put it that way, the magnitude of the magnetic moment. So remember the orbital, the magnetic moment is proportional to the orbital angular momentum. That's the vector, right?
Wait, let me ask you a question. I'm sorry that I'm interrupting. So if I throw an actual magnet through, how would you expect it to behave? Like not split in up and down?
Yeah. Yeah.
So what do you mean?
We're using a bar magnet model of the atom.
So if you threw in a tiny magnet, you'd expect it to either go all the way up or all the way down, right? If I took a speck of dust size bar magnet, so it has, let's say, 1 million atoms in it. I'm assuming a speck of dust is like 1 million atoms or something. So if I threw that, would you expect it to go all the way up and all the way down? Let's say they're completely aligned, perfectly aligned. It's 1 million silver atoms, perfectly aligned. Would you expect it? So you'd expect it to be split up and down?
Yep.
So what do you mean?
Okay.
But that's the question. So what do you mean by that's the classical expectation? So you're
The
saying
classical expectation, there's a velocity distribution
so you're saying
that creates this. So there's always going to be, when you create the beam, you're basically inducing a random velocity. You have the collimators, but they're entering there's a random state that they're entering the apparatus in,
right
or semi-random state.
right. The magnetic moment is in spherical coordinate random it points randomly.
Mhm.
So what do you mean that number 4 is the classical expectation? You're saying, but this experiment has never been done. 4 has never been done on any magnet.
Well, it was done. It's never been observed, the classical result, because if it were, then by definition, the result of Stern-Gerlach would not be accepted.
So you're saying if I take a normal magnet, like a compass, and I put it in the Stern-Gerlach, it shouldn't align.
Yeah, I don't know.
What? What do you mean you don't know? What? Right, you're saying what should it align or should it not align? If I take a normal compass and I put it in the Stern-Gerlach between the two magnets, should it align?
I think it would align with those magnets. They look pretty powerful.
But if it aligns, but we're saying a compass is nothing but a trillion atoms all aligned. But if you're saying that each one of them can only align up and down, up or down, then how do they move so smoothly? Why do we observe the smoothness? Whence does the smoothness come from? Anyway, I'm confused. But
they can assume other orientations that are not exactly aligned to the magnetic field, but that requires energy,
so
which is quantized.
So when an
am I right?
Yeah, I think you're right.
So when an atom
Guys, I don't know how much more I can do. I've been doing quantum mechanics for like fucking 6 hours. I'm
it's
tapping out.
it's okay. It's okay. Yeah, I'm gonna go back to writing my paper.
Okay. But basically that's it. So he realized that the orbital angular momentum would be quantized, and therefore by doing this experiment, they would determine the existence of this hole in the quantum vagina. That's a brand new sentence. Confirm quantum mechanics. So there you go.
But they thought they're going to disprove Bohr or Sommerfeld.
No, they were trying to test the theory, right? So,
but they were sure they were going to disprove. They said we're going to quit physics if he's right. He obviously makes no sense. I don't know where. Okay, I don't know. I don't understand why they thought that according to him it's going to be split.
you have to read the paper. There's a lot more that goes into it.
Okay. All right, I'm gonna let you go.
All right.
Thank you for that explanation.
Mr.
That was
Slade?
interesting. I'm wondering if maybe this is a practical thing to think about.
Well, I just want to say for Mr. Slave,
Mhm.
do you see how you were just engaging with the conversation and listening and asking questions and not monologuing? That was great.
I
think
always
we just had a great conversation.
I always you're welcome, but I always try to be the nicest person in the universe.
Okay, well, you don't always succeed.
Then let me know whenever I'm not succeeding. Let me know because I'm here. I'm just here to have fun.
We all
and have fun first and learn physics too, and maybe 3, like come up with a new theory.
Yeah, fair enough.
So if we're not having fun, then we're off target. I'm off target. Okay, back to writing my paper.
All right, see you, Mr. Slave.
See you. Thanks. Bye.
Bye.
All right, let's go back to my server. Okay, writing paper. The paper mill. I'm a paper machine. I'm a paper mache. I'm a paper mache. Should I close the vendor? Should I close the vendor? I need the line. Let me 1 second. All right. Okay, so diagramos. Let's go pick up a paper, a ready paper. Let's get the latest one. This one, how to. Okay, yeah, we can take this one. That's a good paper. Let's take a figure. Let's go to how to and paste it here. This will be figure 1. Pull this up. Let's go to F11. All right. So, let's clean it up. So we're going to have here the double slit experiment. So this is going to be a general double slit experiment. So we're going to fire, we're going to need a cannon. So this will be our cannon. Let's rotate it about 90 degrees. So this is the cannon. And it will fire a pellet. A pellet will just be a circle, I guess. It's going to be there's nothing better than a circle. Okay, so this is the bullet. This is going to be a particle. So it's going to fire a particle, and then it's going to somehow go through 2 slits. So how are we going to do 2 slits? So I think we're going to have like a block. This will be 1. And then this will be the other side. There's going to be 1 in the center. So we're going to make this a little bit smaller. Something like that. Is that good? Let me make sure that you guys can see my video. Wait. My video. My video. Okay, it's good. So, und 62%. 16. Alright. Maybe we'll make this a little bit more like this. Okay, so how does... So let's bring this one so it's right in front of the wall. And this one is here. And the question is, how does this work? Right, let's have a detector. So this is the detector. So how does that work? This is a beautiful experiment. Right, how does that work? This doesn't make any sense. So this is going to be step 1. Let's copy that. So he thinks I usually try to hog the mic. I try to take over the conversation. I never try to take over the conversation. All right. So the next step is going to be, let's reinterpret this as a wave. If we assume that this guy is a wave, so let's find a wave. I think a wave, I would use maybe this guy for the wave. I don't think there's anything else I can use for the wave. Maybe these guys. Morning Constitutional? Isn't today Friday? Rumble Monkey? Oh, it's just a banner. It's probably something else. Okay. Yes, who is at my door? Miss Rex, how can I be of service to you?
Hey, can you hear me?
Yeah. Can you hear me?
Hey, what's going on, dude? Like, hey, I just want to say I appreciate the work you do. I became a fan on your off your YouTube because I debate vegans. So like, and so yeah, I've been getting into it on the Vegan World server. But yeah, dude. So I wanna. I'm actually glad I'm talking to you.
Wait, that's amazing. Wait, so you debate vegans and
Yes.
and you started because you saw me, or
No, so to be honest with you, so like I started to so I when I came on this well, not this server, but like 2 years ago, I do debates on I'm a pro-life advocate, like anti-abortion advocate, but I came across vegans and I got into debates with them, right? But I got into it with them so it was the vegan server, but it was someone's YouTube channel. I think Jim Bob. And then I think because it was like vegans, and I don't know how I came across your page, but I heard you debate a guy. Oh shit! So you and I are familiar with the guy named Sebi.
Oh
You
yeah.
debated a guy named Sebi.
Yeah,
And
yeah.
I debated him on the pro-life, pro-choice, and he got like. Well, I would say he got frustrated with me. And then he's like, "Well, fucking debate me on the whole vegan position." And then I was looking up arguments on like how to combat name the trait. And I think your server came on my YouTube page, and then I heard you debate him, and I was like, "Oh shit!" I was kind of blown away by that. So yeah, I think like I do like your page on YouTube. That's how I got introduced to your Discord.
Wait, let's hear. So, how do you defeat name the trait?
So this is what I usually argue. So I use a metaphysical experience. So the reason they can, well, I would say name the trait or whatever aspect you want to claim, like a vegan, right? So I would say the reason why I value humans above any other species is because we have established a metaphysical experience. So, like, if there were aliens or a dog or a cat or a worm that was able to display a metaphysical experience, that's how I would counter it. And that's what I got from Jim Bob's argumentation. But yeah, that's like mainly the argument I use for to combat the vegan position.
So you
or I use
You there? Did we lose you? Bad connection? Something is going on. Guess you have to turn off the mic. Okay, I'm here. Whenever you want to continue, I'll continue writing the paper. You can come back anytime. I'll hear you when you come back. All right, so back to the paper mache. So instead of this, I'd like to introduce a something that would look like a wave. So we could use this or this. I think this would look more like a wave. This, and just rotate it by how many? 45 degrees, maybe? So now it's a wave. Now we can magnify the wave, maybe. Maybe. Oh, look at how it's moving, how it's waving. Almost. You see, as it's moving, it's naturally going through both slits. You see? It's like it was born to do this. It was born to go through both slits. Anyway, so we can start from this guy. How can I just let it go? I guess with escape. Anyway, I'm going to copy this guy and move it over and then magnify it. And then copy this one over. One more maybe, and then magnify it. Something like this, and then one more. What just happened? Anyway, what happened to Rex? Rex, I can't hear you. Just letting you know. I can't hear you. Oh, he's gone. Okay. I didn't get a chance to keep any info about him. Oh, shoot. Rex, send me a DM. All right, there you are. Okay. What's going on, Rex? Well, before anything, let me... Oh, we are friends. Let me see our history. If you're open to answer... No, don't call me personally. Okay. Hey.
Hey, can you hear me?
Yeah, but why on a private channel? Why not? It's not working in the room?
No, I tried to go on. It said I was responding to you, and then it would not let me. That's the weird thing, dude. Like, Um, yeah. So I try. Like I was on Voice, and I heard what you were saying, and then I went to see what you were posting, but I was talking, and then it would not let me. Well, you said you couldn't hear me. That's why it was weird.
So Discord glitches all the time. So when this happens, you just leave and come
Yeah.
back. Let's go. Let's try going to the general VC
All right.
again. And if there's an
All
issue,
right,
just
cool.
leave and come back. All right. See you
All
there.
right. All right. Let me go.
All right. Try again.
Yo, can you hear me?
Yeah, it's fine. It usually
Okay.
fixes itself. Yeah.
All right. Cool. Yeah. So that's why I was like, oh shit, am I being censored?
No, I don't
But
censor anyone.
yeah. So yeah.
Mm-hmm.
So I had a question for you. Like, what would you categorize yourself as? Like meaning like religious, non-religious, conservative, or liberal? 'Cause I was always curious on that.
I guess I'm a Trump supporter. I'm not a Biden voter.
Yeah.
I don't think Biden is as bad as as Trump supporters make him out to be. He's not as bad. He's pretty bad. Trump is significantly better, but not. Trump has his issues. I'm not religious. I don't believe in a god.
Yeah.
I'm secular. I'm amoral. I know I'm an amoral egoist, but an amoral egoist behaves very morally. So I'm an upstanding member of my community, of any society, of any community. I'm always a model citizen.
Yeah. That's why I was always curious because I think like when I hear you debate, it sounds like more r- right leaning. Not to
Yeah.
say you're a right wingist, but like I like your style. I like what you debate, and especially like on the vegan shit.
Yeah.
Because I think you debated Ask Yourself, right? Or you
And
try to debate him.
Dr. Avi, they claimed I didn't.
Yes.
Yeah, they claimed I never made a proposition. That's like that's like when you
Yes.
beat up two bullies, you beat them up
Yeah. No.
to a
I
pulp, and they say, "Yeah, we didn't try to fight you."
Yeah, and I think the same shit happened with Sebi. And I even commented your YouTube. There was a YouTube. I don't know if it was your page, and you posted it. He sent me the video. He goes, "Hey, let me know what you think about this debate." Mind you, me and Sebi debate all the time, and I don't like the guy. He's fucking weird. Like, I mean, that's on another note, but he's weird. And he sent me the YouTube. I can send you the screenshot of the DM. He goes, "Let me know what you think." And I was like, "Why do you want me to know? Let you know what I think when you because he claimed I was a fucking idiot on metaphysics and theology and blah blah blah." But for some reason, he wanted my approval when he debated you, and then I wrote on there that Sebi runs from debates, and I analyzed the debate and I took your side. And then he was like, "You're a piece of shit. You're a He got real personal, right? Like he got really weird." But let me hold on. Let me if we're he goes by Mustafa.
Really? So he's an Arab?
Yeah. No, he's not. But let me.
No.
So he blocked me. I'm gonna send you a few screenshots. But Sebi, and then he created an account. He tried to blow me up. He was calling me. The guy's really odd, but his name's Sebi. All right, I'm gonna send you it right now. Hold on. You debated him on veganism.
Yeah, I thought I didn't do well, and then people told me, "What are you talking about? Look at the comments. The comments are all on your side." So I was.
Well, the thing is, he ran. He ran from you.
I don't think he ran.
So,
I
like,
think he just declared victory or something, and then the mods took away. Just kicked me out of the room. So I don't know.
oh, probably. I mean,
He
hold on.
he said prescription, postscription. I didn't know what those words
Yes,
mean,
yes, yes.
and like
Shit, let me try to go to the damn server, but I think he fucking he blocked the
remember I explained.
original.
Look, I don't like. So I don't enjoy debating people on their server or
Yeah, yeah,
like it's not a good. It's always better to debate people on either a neutral platform or on your server one on one
yeah,
quietly, like with no audience. Like people want blood sports, but that's not debate. Like blood sport is blood
yeah. True.
sport, debate is debate. Debate is to figure out the truth together. That's a debate. And the truth is sometimes very difficult to figure out, and takes a long time, and you need the peace and quiet, and you really need to understand the other person, and you
Yeah,
need
are
to.
you familiar with a guy named Senth?
Sure, yeah, he's a. Yeah, I don't like debating him. He's very. It's unproductive to talk to him.
Well, I debated him about abortion. So after that, 2 weeks ago,
Hmm.
I had like three of his friends hit me up, and I offered them debates on it, and it was they did not want to do it because Senth took the position of personhood, but personhood is very it's a subjective view of like when human beings gain personhood in the context of abortion. So like that was like more of um, a debate we had, but also on the vegan server. I brought up the whole metaphysical experience thing, and he was like, "Oh, you're just trolling me," blah blah blah.
Yeah, when they say you're trolling, that's obviously an ad hominem, and so that's when they don't want to debate. They're not truth
Yeah.
seeking. Wait, but you believe in God? I am sensing.
Yeah, so like I do believe. Well, I'm a Catholic, so I take a more virtue ethics slash deontologist and natural law like that. You can say I favor that,
Hmm.
but I am open and I understand different philosophical like positions with ethics, especially when it comes to ethics.
I am
Yeah.
unethical. I am amoral. I reject all
Oh,
ethics.
oh, interesting. So are you? Well, what would you if you reject all ethics?
I'm an egoist. So I'm an
Yeah.
egoist, and I want to optimize my life. Because I want to
Okay.
optimize my life, I want to live in an optimal society.
Uh,
So I don't want there to be crime. I want my society to punish criminals, and if there is a criminal, I will be on the side of the law against the criminal, and I would even risk my life to defend society against criminals. Because if all men don't stand shoulder to shoulder against evil, then I lose. Society loses, therefore I lose. So
yeah.
therefore I will jump on a grenade and maybe die in order to protect my fellow men.
Well,
Because
I mean that I think that's an interesting perspective, right? So like what you would have to ask yourself as an egoist, why would you worry about defending others if you're going to die and get blown up? Like if there's no other concern after you die, you're just no like you can die for any cause, right? It can be the bad or the good, whatever we define. But if someone dies for others, I would say that's the greatest sacrifice.
I'm not dying
So
for
if you were
I'm not dying for others. So I'm an egoist. I wouldn't do anything if it's not for optimizing my life. So everything I do is to optimize my life. But in order to optimize my I can't optimize my life if I'm not living in a nice neighborhood.
Well, true, but what about if you had no other option but to live in, like, let's say, um because you said optimize your own life. And let's say if you were, I'll use more of a vegan type of argumentation, is if you can eat human meat and it's optimizing your life, would you think then cannibalism is okay?
Yeah. Cannibalism is
Okay.
okay
Yeah.
if it's in if somehow it optimizes my life, it's part of a path of self optimization, it's fine. For example, if a person dies and he's healthy
Mhm.
and the meat is good, I would eat him. For example, like there's no issue with that.
Okay.
There's no technical issue, and everybody agrees that if you're stranded on an island, then of course you eat each other when you die. So there's no cannibalism. There's no problem with it. We usually don't do it because we have chicken, and chickens are tasty, and we honor each other's dead corpses. So we bury each other. We don't bury the chicken
Oh yeah.
bones that we eat for lunch.
Okay. No, and I get that, right? But like, what about if I'm just using some reductios?
No.
If we were to eat chicken and humans, right? And they give us the same benefit after someone dies, and you can, let's say, grind them up as a hot dog or a burger patty as the pig or as the human, there would be no moral difference in what creatures you grind it up if it's going to be beneficial to your health or your
So
own
in so
egocentric.
so in general, I don't do whatever I like, right? I live in a society with norms, so I don't do whatever I feel is optimal. I might feel it's optimal, many things I would feel are optimal, but I don't do
Yeah.
them because I live in a society and society has laws. Some of them make sense, some of them don't, but it's fine. I try to follow, what everybody does, I also follow. So therefore, we don't eat human corpses. So I don't. We actually honor human corpses and we collect every last bit and deliver it to the family so they can mourn every bit of.
Yeah.
Mhm.
Yeah, yeah, pretty much that'd be moral consideration of like of our species, and more of like a social construct,
Exactly.
right? Like, yeah, like, so I do understand that contention. But
But for
I
me,
do got to get, I got to get to bed. But I
mhm.
do want to say I like your server. I'm sure we disagree and agree on a lot of
Yeah,
things.
yeah.
But yeah,
Co-
dude, if you can, well, I want to send Mustafa a DM or whatever to debate you again.
only,
He's gonna get really pissed off at
only,
me because I
only.
can't stand the fucking guy. Go ahead.
Yeah, it's fine. He can come. I'll entertain him, but as a friendly debate, I don't want it to be like if I feel, I'll try and
Yeah.
stress the point that I don't want to like usually I PTSD after harsh debates, and
Right.
it destabilizes my life. It makes my life unproductive. It's not worth it.
No, I feel you. I feel you. No, because I'll be honest. Like, it gets tiring debating on many topics, but in general, it's time consuming. It's exhausting, but
Yeah.
all right, man. You have a good night. You
All
take
right.
care, and
Come. Yeah.
I'll keep following you on
Yeah.
YouTube and
And
keep
come.
posting up the vids.
All right.
Keep posting up the videos,
And
man.
and come visit. Say hi every once in a while or whenever you
Yeah.
want.
All right, man.
All
Take
right,
care.
man. Take care. Bye. Okay, let's get back to the papeles. Master light the papeles. Okay, so when it comes, you already see how the wave makes so much more sense. Like, it's so ridiculous not to entertain the wave model. Right? The pellet doesn't want to go through. The wave, it goes through whether you like it or not. It just goes through. It's so perfect. It's so natural for this thing to go through. I think that's it. That's it. Obviously, the center one is not going to make it, so we're going to turn it into this, and oh, they're on top of each other. Jesus. Okay, so Shift Tab. Yeah, this one is also right. Okay. Theoretically, this is what should happen. Right? Instead of the pellet. So this is instead of the pellet. So this is the wave model. This is figure 2. The wave model. We need the bottom to be dedicated, a dedicated area. Let's maybe move this a little bit up. Oh, that's not what I wanted to happen. I wanted to take this and move it up to here maybe. And the same goes for this guy. Boom, like this. Okay. So that we can use this area to do this. And then this goes to here. So this is figure 2. The wave model. So the first one is, I would say, the particle or the bullet model. So this is figure 1. So we need to do the same here. So this is figure 1. The particle or bullet model. And you see the issue. It's going to bounce, right? So if we, right, it's going to go here and just bounce against the wall, the thing. Let's make it transparent. They can't see it. So make it thicker. Even 4. Oh my God, Jesus Christ. Make it 2. Oh, it's impossible. Maybe we can just make it normal like this. But maybe we can make it grayish. Maybe move it to the left a little bit. You know what? We can just use a bunch of these. Something like this. So you can see the problem. It's not going to go through. This is the problem with, obviously, with the bullet. You can obviously see the problem. You don't need me to. Right, we can even use the explosion 2. What about explosion 1? You see the problem. It's going to impact. It's going to impact. It's going to impact on the surface. So the bullet, the particle / bullet model makes no sense. It impacts immediately on the double slit. Well, it might impact. It might go through one of the slits. That's one option. Another, right? It might impact, might not even go through, or it might go through one of the slits. We can just write, or at best, it might go through one of the slits. It's gonna bang, 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 bang. Maybe it will go through one or the other slits, but it's going to end up creating a mound here and a mound here. That's it. Nothing better than that. But everybody knows that already. That is the problem. Whereas this is figure 1. Figure 2, the wave model immediately goes through. There's no problem. It goes through and creates an interference pattern. So we can continue and show the interference pattern. So we can take this and take this guy, copy over to here, and make it narrower, make it smaller. Like this, basically. So it's going through. And as it goes through, it's going to regrow. 1 second. Let me save a message. Oh my God. La 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 la. Why is life like this? If you keep living, you will probably find someone better. She will keep living. She's sending me a message. I can't listen to the message. 1 second. La 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 la. Mm-hmm. Mm-hmm. 1 second. Let me hear her message. Oh my god, my mic was off. Oh my god, my mic was off. I'm so sorry. I'm so sorry. My mic was off the whole time. Oh, this is so terrible. This is so terrible. I was explaining it and explaining and explaining, and my mic was off. Absolutely terrible. Okay, whatever. Look, this is the paper. Anyone who reads it will immediately comprehend it. It's really very straightforward. I think that's enough. So, how do you share this? Share anyone, copy. Oh, I think I already shared it, but let me just move it. This is now, we can move it from in progress. This is how to resolve. This goes into the ready papers. Move it. Ready papers. How to resolve. It's fine. Let's go to the server. Let's see what they say.
That many apps and new apps coming along all the time. They just don't really have time to check them properly. Yeah.
Months and months. It's not like an investigation on John Wayne Gacy or something. This is quite simply, okay, we'll make a fake account. We'll put a password in. Now we'll see if we can get other people. We can. This is wrong. Bang, you're down. Like, you know, a copper has to come and chase you if you're speeding. He's got to get you. You know what I mean? Or if he sees you robbing a bank, he has to stop you. He can't say, "Oh, I'll just let the armed robbery squad deal with this," even though you know what I mean. And Google, as a proprietor, as a store, I mean, it's your image too. You don't want anyone going in and giving credit card information to somewhere where you know might be compromised.
Of course you don't.
Even if you get compromised and get it all back, it's a pain in the ass. You've got to start doing things. You've got to go and change all your old passwords, and some of them you can't remember, and then you've got to put it into little password wallets, and then hackers can see that, and so on and so on. So yeah.
Yeah, and I suppose at least most of the flat earthers who downloaded that app use the same password everywhere.
Oh, look, a lot of people do tend to use the same one because the amount of criteria they give you, like cabbages. Oh, can you make it a capital C? Can you give it a capital? Oh, capital C. Then can you put a number in? 10 cabbages. Can you make that not plural? Fucking 10 cabbage. Can you not use a dictionary word? Yeah, for fuck.
No, for my most important.
Give me a fucking password or I'll shove you.
Yeah.
Taken.
Now, in my most important places that I use like a two-step. Where I have to use my fingerprint as well, or use an authenticator.
Yeah, and for me, anything out of my little fast-moving money thing, my little wallet, you call it, I guess. It's got to come back to my phone with a password, with that 4-digit number. But I guess they can just change your phone number and make that second tier go to their hacked phone. Mind you, it's a bit more.
No, I don't think so. I think if you change your phone number, you probably have to reset everything. Are you?
Well, not recently, 3 years ago when I had to do a change because I did go to a different phone number. I had to go in and do it personally at the bank with photo ID and all that sort of stuff.
Yeah, but we had to do that as well. But that was due to new rules and regulation. In fact, even though I had a mortgage and all my salaries in that bank for more than almost 40 years, I still had to go in and identify myself. There was some sort of new rules and regulations.
Yeah.
Hey guys.
Ah, it's Mr. Slade.
Yeah.
You had a nice break.
What do you mean break?
So is the two-tiered stuff? Sorry, just to finish up, is the two-tiered stuff now insecure as well, or is that? Because I've heard both sides that two-tiered, two-factor authentication just adds something, but they can still get around it, and others have said it's secure. So which is the true? Do we know?
I think it makes it a hell of a lot more difficult.
Yeah,
To use like an authenticator.
Yeah, there's no absolute. There's no absolute.
When I log in like to my work, let's say email, and I haven't been there for a while, I need to do the two-step. So I have to log in with my user and password, then my fingerprint, and then the authenticator will send me a code that I need to put in.
Citation needed.
Veritasium made a video where he showed that he can bypass two-factor authentication. So everything is breakable. There's no absolute defense against hackers.
No, but it takes a hell of a lot of work.
Yeah.
And it might not be worth it.
Yeah. Yeah.
I mean, I work for a really big company where IT security is focused on all the time. So
yeah. So like security, they say it works in layers. The more layers you add on your security model, the more secure you are. But there is no absolute security. Anyway, I wrote a paper.
Yeah, that is the point.
Yeah, sure. So I wrote a paper, short paper, showing the advantage of the Aether model when it comes to the two-slit experiment. Do you guys want to test stress?
Conversation over.
Why?
Yeah. Another thing,
really.
before you go on, you should be able to give us some evidence for Aether to actually exist.
Yeah, that's a paper.
Otherwise, it's just a hypothesis.
Well,
using known
We're gonna
physics
need
and
to
trying
see
to.
that actual citation is what he's trying to say.
Well,
and look, Mr. Slave. I mean, you just walked in, you said one thing, and you did a left turn, make it about you. Like, I mean, I just saw Rui drop in and a few other people who were more polite, and perhaps. Do you think maybe? I mean, you've been doing this all morning, and I didn't come here because you were doing your Aether thing. I mean, do you really have to change it to you? Like, can't you just let the convo flow along, or is that beyond you?
It's like it's a public room. I mean, if you look,
yeah,
look. No, if nobody, I'm asking, right? I asked, do you guys, are you interested in hearing? I am not gonna force
No.
myself.
Already
heard it. Nobody wants to hear it.
No, not really, because because what you do, you start off with the basis that Aether actually exists, and then you try to reverse engineer and force known physics to fit your model. Okay, as a hypothesis, fair enough. But before you have any solid evidence Aether existing at all, it doesn't matter what you do.
Right, but look, I just took the double slit experiment, and I'm trying
Doesn't matter. You're still trying to reverse engineer the double slits to fit your model of Aether existing.
No. I'm looking at the double. No, I'm looking. Look, I don't know if there is Aether or not. I don't know.
Then why speculate?
Look, I'm looking at the double slit experiment. I'm looking at the double slit experiment, and if you look at the double slit experiment, assuming no Aether, like assuming that particles are like bullets, then you're very far. You don't match the data. You cannot reproduce. The model does not reproduce the data at all. Right?
What do you mean? Like the wave
Oh,
pattern?
God.
The wave pattern does not conform to
Well, if
what's sent through the slits.
Well, if there is no ether, then I'm assuming that the particles are like bullets.
No.
Well, so right, so it's either. I mean, either the.
Hang on. Could a particle like an electron or a photon be regarded as a wave?
Yeah, but that I would call that.
Okay, yeah, I rest my case. Then what's the point?
No, because I would say then what is it waving through?
It doesn't need electromagnetic radiation. Doesn't need to move through any other thing than space itself. It's not like a mechanical kind of thing that you have, let's say, waves in water or in air or something like that. It does not need a medium to propagate.
How? That doesn't. That contradicts logic. That contradicts it.
No, it does not. It does not, because you have decided that everything has to be mechanical, which means that any radiation has to propagate or use some sort of a medium to travel through. That's not the case.
Look.
Oh, hang on, guys, if I may. The question was asked, does everyone want to talk about this? To which I heard a couple of people say no, and Alex has put his picture up of, hopefully, Alex has got a picture there. Is that right, Alex? And look, Mr. Slave, you were told no, people don't want to talk about this, and yet you've spoke about it. For fuck's sake. I mean, is that dumb or what?
I also wanted to pull Alexander up on why has he got his video feed in flirt mode.
Oh, okay. Turn your camera around, Alex. Yeah, I'm sorry, guys. It's just that, when we hear the propagation through the ether, I've got a paper. Look, Mr. Slave, with all due respect, how many hours have you been doing this for today, and do you think it's a fair amount on the rest of us? Because some of us are here for a convo that doesn't involve you. I'm sorry to say
Yeah,
that.
there's other topics to talk about, Mr. Slade, besides the one trick pony
but he's
conversations
yeah.
that you bring up.
He's desperately looking for attention, and hopefully, if it goes on long enough, it's like a child. If you go on, and then people give up and say, "Okay, yeah, you're." That's what it sounds to me like.
I don't think that's fair.
No, I asked.
Well, it's an observation. It doesn't matter if it's fair or not.
No,
that's my take on it.
I just asked if people are interested in this discussion or not. I'm not gonna force.
We said no.
I just think he's hyper focused on one thing, and that's what he enjoys thinking about.
He's a one trick pony. One trick. You know the phrase?
It's a one-trick pony. Sorry, it's a one-trick pony. Is that sorry, Terry? I didn't. It's just
that's all right.
Alex has got some pictures up his camera, so. And
Alex, we didn't say you couldn't use your video camera while you were driving. We're just saying that you're in flash mode.
Yeah.
You can't. So you can't use the camera while you're driving.
No, I didn't say that.
Oh, what did you say?
I said you don't. I said your video feed was in flirt mode.
Do you guys know who?
Yeah,
do you guys know who Robert Merton is?
So that's flirt mode.
It's so nice out here. It's beautiful. Like.
Right. Now you've got it in flirt mode.
Can you see that I'm heading west because of the sun over there?
I think somebody
take it out of flirt mode. We might be able to see.
I'm coming down the mountain. Oh, my brakes are getting a bit.
Woo.
The sun does rise in the west.
Alex, Alex, can you actually hear us?
Yeah.
Well, take it out of flirt mode.
And why do you drive on the wrong side of the road?
Sideways. He's saying it's sideways. Clearly, Alexander doesn't realise what flirt mode is.
Doesn't know what flirt mode means. Flirt mode is portrait. You've got to do it
Yeah.
normal, like us normal people, and have it in landscape.
All right, I've got a meme. Hang on.
All the flesh do it in portrait.
Oh my god, these people are so boring. These guys don't know anything. They just come in. Well, I don't know what they know. I don't think they know anything. I don't know what they're talking about. Flurf mode. Anyway, so I'm sorry I didn't present my paper. Okay, the point is that what is wrong with the word wave? As they split into two waves resolved, we will show that most of the paradox of the double slit experiment is resolved. Yeah. Okay. So diagram. This is diagram 1. You see that the particles, they either go to here or to here. Well, it's 1. So what's the difference? This is multiple particles. This is either this one or this one if it's a single particle. And if it's many particles, multiple particles, it's both. But it's completely, it cannot resemble the data. But if you just assume ether and you have waves, now they're saying, no, we don't need ether for the waves. Okay, then what is it waving through? What's going on? Oh, I'm not sharing. Oh, Jesus Christ, help me. Jesus Christ, help me. Oh my God. This is just, I'm having a bad day. Bad day. Anyway, so how to resolve any double slit experiment using the ether model. Does anybody want me to put his name on this paper? Is anyone interested in their name on the paper? Anyway, so the double slit experiment is a known unresolved problem in modern physics. Modern physics assumes that all elementary particles are, as their name suggests, particles. As particles, when we fire them through a double slit, we expect them to behave like bullets. We expect them to create a double pattern on a detector. We are all very confused when they don't obey this prediction. Instead of a double pattern, they create a multitude of patterns. Okay. They behave as if they were waves. But but for some bizarre reason, we keep on claiming that they are particles. In this paper, modern physics keeps on claiming that they are particles. In this paper, we're going to give another model a chance. The other model of what elementary particles are is waves. But waves in what? In this paper, we will assume that they are waves in the ether. Indeed, the ether was invented in order to allow light waves to propagate through space. We later discovered that light is physicists later discover that we should keep the word physicist. They discover that light is an elementary particle called the photon. But as we are now planning to do in this paper, we will redefine the photon as a wave, or more accurately, a quantized wave, or a wave packet. But in no way will we analyze a photon or any elementary particle as a particle. What is the photon? But what is the photon waving in? But what is the photon waving in? Just as light did, so too is the photon. It is waving in the ether. And the same goes for the electron. We will analyze the electron as a quantized wave in the ether. We will see that as a wave, both the photon and the electron can easily go through two slits at the same time. As they split into two waves, these two waves can now interfere with each other and create a constructive and destructive interference pattern. We will show that most of the paradox of the double slit experiment is resolved via the Aether model. We do agree that some of the double slit experiment paradox remains, but we will argue that the Aether model offers a simpler and better scientific explanation to all double slit phenomena. Very good. That's a good introduction. Diagrams. So this is a diagram. One. This is the particle or bullet model. The particle bullet model makes no sense. It impacts immediately on the double slit, or at best it might go through one of the slits. If we fire a single particle at a time, at best we get two regions. This does not reproduce experimental data. 1.2. The particle bullet model does not resemble experiment. Multiple particles do not reproduce experimental data at all. The wave model, this is figured, yeah. The wave model, we should maybe call this 2. It's a little bit confusing. So this will be 2. Figure 2. 3. Figure 3, the wave model based on the ether fluid assumption resembles experiment. At least resembles. So 1, in the wave model passing through two slits and what in the wave model? In the wave model passing through two slits and the interference pattern are immediately resolved. In the wave model, the challenge of a photon or electron passing through two slits simultaneously and the interference pattern are immediately resolved. Mm-hmm. Two, oh, it's not big enough. Two, we expect to get an interference wave pattern for even a single electron, but we don't, which is weird. But it is a better model than the particle bullet. Yeah. It's not perfect, but better. Right? All we can offer is better. Better than yesterday, as Coach Duchette, Greg Duchette says. Better than yesterday. And that's it. Thank you very much for your attention. Did we record this? I should make short videos of these things. Yeah, this is very good. This was actually the first thing I realized. This is what made me so excited about the Aether model. Okay, everybody. Let me see if they're still talking about nonsense over there.
We're lucky.
Cool.
There might be some. Yeah.
Well, I don't think
Yeah, it's
koalas
good
move
spot.
very quickly.
No,
It's gotta
that's
be getting pretty hot there now.
Yeah, during the day, yeah. It's nice and cool out here. So the reason I'm coming out here is because of the low light pollution. Low, like, so it should get very dark once the sun drops.
Wait, you're doing
And
a
I'll be able to see heaps of stars.
oh you have a telescope?
No, I've got a Canon with a telephoto zoom lens, so I'll be able to zoom up. And I'm trying to get photos of that comet that has been in the sky the last couple of weeks.
Is it a P900?
Wait, there's a comet right now in the sky?
No, there's a comet. Yeah, and
So,
if
so,
we're lucky,
so if
I
anyone's
should be able to see it.
interested,
Yeah.
if anyone's interested, I got my camera on and
We lost you.
Terry, whatever it is you've done, you're fucking up the VC.
okay, I don't know what I've done.
We'll put your camera on. Everything went yellow, facey mics and blipped and whatever.
I wish we had somebody to talk about Aether.
So your Canon feed goes into your laptop?
Yes. Yep. I've got a Canon webcam utility which feeds my Canon like what my Canon is shooting will come straight into as a webcam feed. Yeah. Through Discord. So I've got my laptop with me to do that. We've done a couple of moon sessions already. So I wanted to see if we could capture the comet on the camera.
So but the Canon, the lens is basically a telescope, right?
Yes, it's a 55 to 250 millimeter zoom lens.
Wait, can you
at 250 millimeter focal length, it should
can you show us the camera, the lens?
zoom in pretty
He's driving.
well.
He's driving. So bear that in mind.
When I'm not driving, yeah. When I pull up, I'll.
Wait, I thought.
In the afternoon.
Wait, isn't Terry the one talking? Who's talking? Terry, are you the
Aether man?
Hey, look, there's the western. There's the western sky. The sun has just set. We should have really good visibility of this comet because there's no clouds. It's beautiful. It's like perfect. Couldn't ask for better weather.
Wait,
not ask for better.
But the sun is setting or the sun is rising for you?
Here's the intersection. The sun is setting in the west. I'm facing west right now, or almost west. The sun is like.
Are you in Australia?
Just about over that hill there, like in that direction.
Australia doesn't exist.
Of where I am. Can you see that sign?
Yeah.
Somerset Dam, Fernvale, Brisbane.
Oh, Brisbane.
I'm gonna go this way.
I think Brisbane is in Australia, right?
A lot of people do doughies out here. It is. Look at all the cows over there. There's cows off in that paddock. Dude, this is gonna be fantastic. Yeah, do you get many of these signs where you live? On the side of the road? Like, let me show you.
Hot micing, Terry. Terry, you're hot micing.
I'm not saying anything.
We can hear.
I'm not speaking.
Oh, somebody's wife is speaking.
You see that sign?
Alexander, your video is stuck. Oh, now it's moving.
Terry, you're hot micing.
Oh,
You see that sign?
kangaroo. Oh, koala. Awesome. Oh my god. Okay, alright. What else can I do? I was gonna do some math. You know what? Let me take a break. Maybe I'll come back and do some math, or maybe we'll call it a day. All right. Did I share this? Yes. At least I shared it. You know what? We can watch some YouTube or some X. Elon Musk.
Reentry and splashdown systems used for our astronaut return.
And it looks like we are starting to see the first crew member be extracted. I'm not sure if that will be Commander Matt Dominic or Mike Barrett, but
They should have an elevation, so they should place it on some elevation so that they can step out without crawling out.
it is typically one of those middle seats because they're easiest
Oh, it's live.
to reach.
I thought that's Elon.
So again, you do see that crew member getting some assistance. I can't quite tell who it is just yet.
I can only imagine what it feels like to have to stand up after spending nearly 8 months in space and having to stand up for the first time with Earth's gravity.
And that is NASA astronaut Matt Dominic, who is now out of the spacecraft.
That's so uncomfortable. Like, why put the feet up? Feet should be a little bit lower.
Spaceflight. It looks like we're getting some handshakes there.
High fives all around.
Jesus, look at that thing. All burnt up. Okay. Mucho interesante. Voter ID should be required nationwide. This is voter ID. It's wild to me that I had to show my ID to buy this stupid thing, but did not have to show my ID to vote for our future. Yeah, it's crazy. Ridiculous. For everything you need ID, but to vote? No, it's fine. Yeah, anyone can vote. How is it going in reverse? That's what I don't understand. Really, really weird. I just see counted 99% of the votes in 6 hours. Maricopa County needs 10 days. Just so everyone knows how she got her start. That's her? That's her now? What? There's no way that's her. Really? So she was hot. This would you're trying to help her get elected. Civil War alert. RFK Jr. exposed it. Oh yeah, sure. What's going on here? Fake asylum seeker strangles a female supermarket employee in Spain, and then steals money. More and more atrocious crimes. Oh my God. Asylum seeker. Yeah. We're in Spain. That's good. That's good. I mean, pay close attention to the guy with the black phone. Alright, whatever. I just asked one simple question. Why didn't she do it? Why hasn't she done it? She's been there for 3.5 years.
I just ask one simple question. Why didn't she do it? Why hasn't she done it? She's been there for 3.5 years. They've had 3.5 years to fix the border. They've had 3.5 years to create jobs and all the things we talked about. Why hasn't she done it? Because you believe in things that the American people don't believe in. You believe in things like we're not going to frack. We're not going to take fossil fuel.
Would you ban offshore drilling? Yes, there's no question I'm in favor of banning frack.
Things
All
that
right.
are going to make this country strong,
Then
whether
go
you
home.
like it or not. We're a failed.
Mel Gibson confirms reported that he is officially voting for Trump. That's good. A woman converting to Islam is like a black person converting to slavery. Oh my God, look at that. Jesus Christ. He lowered your taxes and hurt your feelings. Gazans in the masses evacuate Jabalia, Gaza. Sources in 1994, Donald Trump slept with a high-powered married mayor in order to gain political appointments, large paydays, and a free BMW. Oh wait, wrong candidate. That's her? She slept with him? Wow. Abort our own children, import hostile immigrants, disarm ourselves. Yeah. An immigrant who urinates in public in Russia is educated by a Russian patriot.
Уебак, ты охуел на моем районе, Сать? Ты чё, бля, мразь, нахуй ёбаная, блядь?
Oh my God.
Пидорас, блядь, нахуй, охуевший, блядь. Ты не у себя, нахуй, бля, в ауле, блядь.
Jesus
Уебак,
Christ.
ты охуел на моем районе, Сать? Ты чё, бля, мразь, нахуй ёбаная, блядь?
Oh my God, he punched him.
Охуевший, блядь. Ты не у себя, нахуй, бля, в ауле, блядь.
I don't know if it's a good idea to do that. I'm so sorry that bad man touched you inappropriately. Let's wait 30 or 40 years until he runs for office against a Democrat. Yeah, basically. Eliminated. Awesome. Awesome of awesomeness. No way, these two are Mossad. Okay, I'm not gonna show. Vamos la Israel. Missão KC completa, falta um. All right. Let's go YouTube. YouTube me. What is charge and what is mass with James Aratoon?
Minus 10, 9, 8, 7, 6, 5, 4, command enter, 2, 1, ignition.
All right, the New Shepard has cleared the tower and is heading to
Minus 10, 9.
Incredible. 33 engines running. And there's a new version coming out. This is the previous flight, I guess, or the first flight. Yeah. Flight 1 at this point was flailing.
Dumbest ways people got out of jury duty in real life. Crap solar battery?
How many points does it take to...
There's this big misconception that the Great Wall of China is visible from space, which it isn't, but here are some things you can ask.
What happens if a pilot needs to eject from a helicopter?
Have you ever gazed up at the stars and wondered?
No, you guys still making the X?
Yeah.
Are you guys still gonna do the crazy doors?
The crazy doors. Those doors are exercise and hubris. That's for sure.
Well, there's a lot of things you do as an exercise in hubris.
But they're very cool.
They're functional though. If like you're in a tight spot.
Those doors will open up tighter than almost any door out there. Like they'll open up in 18 inches. You got an 18-inch gap between you and the next car. That door will open.
That's pretty amazing. No, you guys still making the X?
NASA's solar probe has gotten closer to the sun than ever before. After years of spiraling closer to our star, Parker's solar probe just broke its own record, which is...
Anybody from Nestle here? They're selling...
Crap solar...
Anybody from Nestle here? They're selling two, you know the new Nespresso type machines where the pods rotate? They're selling two of them, the manual and automatic version, at the same price. If you can't make sense of a choice, you can't make the choice. What would confuse people? If you had a better product and it was cheaper, people would go, this doesn't make sense, because if I had a better product, I'd charge more for it. That doesn't make any sense, so I'm not going to buy either of them. That's why low-cost airlines, when they launched, had to make a lot of noise about what you didn't get. Do you remember that? You don't get checked-in luggage, you don't get a meal, you've got to pay for your coffee. Now, that sounds really weird, doesn't it, in marketing terms? Why would you make a lot of noise about your weaknesses? And the reason is, it makes the low cost believable. If you'd launched Ryanair and said, we're just...
Yeah, this is nonsense. This guy is not an economist. This is nonsense. Whatever people do is to optimize their business. Every step is an optimization. There's no nonsense like what he's saying. That doesn't make any sense. That's like chess. No one plays chess in business. You have competitors. Everyone does the same thing to optimize. It's just the optimal path. It's like nobody goes home. Everybody goes home in the optimal path. It's not like I'm whatever anyway.
Crap solar battery? What other fake...
There's a fascinating thing about hares, which is when they're chased by a dog. If you've ever seen it, I'm sorry, I don't want anybody to think I go hare coursing, but if you've seen it on YouTube, okay, just to be clear, the hare will basically just leap around at random, suddenly jump in the air, then it'll take a violent left. The hare actually has no control over this. The brain enters apparently a kind of random number generator. And the hare doesn't even know itself what it's going to be doing.
That's true for literally everything in the universe. You don't know why you're saying this right now. This is completely automatic.
And the reason for that is if the hare did know, it would give away telltale signs that it was about to turn left.
What happens if a pilot...
There's this big misconception that...
Rare Historical Photos, Part 25. First, though, there was the first ever detailed photograph of the moon during 1840, taken by John W. Draper from the roof of New York University. Talk about an early shot of the night sky.
Why did insurgents in Iraq freeze their mortar rounds when setting up ambushes, possibly being a battlefield urban legend?
Remember when Hyundai strapped an Olympic swimmer to a car's exhaust pipe? To show how clean the emissions from their fuel cell-powered vehicle were, Maria Belmont was sealed in an air bubble attack.
He would use his arms and his legs. So overdue.
Oh, shut up, I'm landing in A380. You're 2 hours away.
Why did the British weld dangling tracks to their tanks from behind? During
this entropy control
discovered by NASA, BD06.
More?
So how does he have 30 employees? He doesn't have a producer for his life. Where are all these employees at? If we can't make Karen work, and despite all these, there has nothing for here to make sure.
Alright, I heard this already. Twin Cities Aviator?
And we have movement. Click on.
Oh God. Oh wow.
Hey guys, my name is Eliel Parguli. I'm a postdoctoral fellow at the NASA Propulsion Lab, and this is I'm going to explain to you why you probably don't understand Maxwell's equations. And even if you think you do, mathematically you think you do, we're going to show you that you probably don't have like a deep intuitive understanding of it. And this is something that's very important in physics, is that whenever you learn about something in physics, whether it's mechanics or electromagnetics, you don't learn how to just like solve a bunch of formulas and just move on. You need to actually understand the formulas. You need to understand what they're describing. You need to like feel it. It needs to be like that level of understanding. So that's exactly what we're going to do in this video. So I'm going to go over these 4 equations, and I'm going to go over it in a very simple way, very intuitive. Doesn't matter if you don't have any formal physics training. We're going to be explaining this in very simple terms again, so you can develop a deep intuitive understanding of it. And just so you know, Maxwell's equations are basically the most important equations to understand in the field of electrical engineering or electromagnetic physics. They are the 4 equations that determine the behavior of anything electrical or electromagnetic. So anything from this cell phone that's recording me to this light over here, to like any electronic device, any piece of software that's running. All these things are sitting on computers and electronic devices, and these electronic devices are governed by these rules as well. So it is very important that you understand these equations, especially if you're trying to be either an electrical engineer, an electronics engineer, or a physicist. So as I usually like to do, in this case you see there are 4 equations. This one is Gauss's law for the electric fields. This is Gauss's law for magnetic fields. This is called the Faraday law, and this is the Ampere-Maxwell law. You don't need to know what these laws are called. I'm just saying the names to give credit to the people that formulated them. But what you need to understand is how they actually work, how they're called. So how do they actually work? Let's go ahead and
So Maxwell,
for magnetic fields. This is called usually like to do.
so Gauss, Faraday.
So anything from this cell phone that's recording me to this light over here to like any electronic device. Understand these equations. This one is Gauss's law for the electric fields. This is Gauss's law for magnetic fields. This is called the Faraday law, and this is the Ampere-Maxwell law. You don't need to know what these laws are called. I'm just saying the names to give credit to the people that formulated them. But what you need to understand is how they actually work, how they're called. So how do they actually work? Let's go ahead and take a look at it. So I'm just going to go ahead and be very clear on something that, as you can see, there's an
I'm going to try and guess. So the first one says that I think it's the divergence of the electric field is the electric density, the charge density over the permeability of the ether. So the divergence in the electric field is equal to the charge density. Yeah, but you have to visualize it. What does that look like? That's a good question.
equal sign over here, and all of them. And this equal sign, I want you to understand something. The way I like to understand physics is I write f of x equals x, just like how you do in math, just like how you do in programming, where some behavior in x causes some outcome in f of x. So this left-hand side, this is a function, and this function is an outcome, it's an effect, and it's caused by a change over here. So we're going to treat everything on the right side here as the cause, and we're going to treat everything on the left side as the effect. In other words, anything that's happening on the right side is going to be causing things that are happening on the left side. Now this looks like a big mess, so let's go ahead and dive into equations one by one. So the first one, Gauss's law for electric fields, or for electrostatics, is pretty simple. It's basically showing you, and before I even explain what causes the electric field to happen.
Wait, he's gay. He calls himself Ali the Dazzling. That's gay.
Let's first talk about the del operators over here. So obviously we see here there's an E, there's a vector. This is the electric field. We don't care about that right now. What we're interested in is understanding what the hell is this like upside down triangle with a dot, right? So this upside down triangle with a dot is describing divergent behavior. So for example, if I have some type of dot over here, this divergent behavior is like anything that's going outwards in equidistant lines. So in this case, this is the divergence of the electric field, meaning the electric field is going outwards. It's going like equally in all directions. Like that. Probably look ridiculous doing that. But that's basically what it's doing. So whenever you see this del with a dot next to it, this is divergent behavior. Alternatively, we're going to see in the later third and fourth equations, it is not a dot. It is a cross or an X. And this is called curl. This is like basically, instead of divergent behavior, this is more like rotational behavior. That's like curling around something or rotating around something. We're going to dive into that a little bit. But it's very important that you understand this notation. So the very first
The curl discovers a turbulence.
one, which is Gauss's law for electric fields, it's pretty simple. It's just saying that some rho is basically charge density. So if I have any type of charge that's sitting in space, like let's say whether it's, well, in this case, this is charge density. I'm going to write this in a way that's probably going to piss off some of the mathematicians and physicists, but just so you get a really deep and intuitive understanding of it, we're going to get rid of this rho over E naught. This is the permittivity of free space. This is basically how the behavior of the electric field is going to be shaped, whether it's in a vacuum or like if it's in a different material, then it's no longer, you're moving on and then you change it based on the material. I'm going to get rid of all that confusing nonsense if this is the first time you're being introduced to this. I'm just going to put like a squiggle here that says this is sort of equal to Q, which is charge. Now, obviously, charge is related to charge density because at the end of the day, charge density is just how much charge is flowing over a certain area. So I'm just basically going to replace the rho with Q, and I'm going to add the squiggle. I'm going to say it's not exactly equal to it, but kind of sort of what it is. Basically, anytime you have a charge, like a plus or a minus, if you have some type of charge.
He's a good teacher.
especially like an accumulation of charges over like a certain surface or a certain volume, in this case that's what the rho is, that charge is going to create some type of electric field, which is basically a field in which there is a force to be felt, right? At the end of the day, the electric field is just wherever you exist within that electric field. Obviously, the closer you are to the source, the stronger you feel it, but you're going to feel some type of pull or push. You're going to feel some type of force that's exerted by this electric field. So all the very first law, Gauss's law, is telling us that in order to generate an electric field, the effect, you need a cause, which is rho, charge density, right? And then obviously, because of the E naught, the permittivity, this is also a signal that the electric field's behavior is going to depend on what material you are in it. So I'm going to rewrite this to be the correct form, which is rho over E naught. So basically, these two variables, well, this one is usually a constant, but if the material is changing, it becomes a variable. These two over here, the rho and the E naught, are basically going to determine what kind of electric field you're going to have. But we know for sure it's going to have divergent behavior, right? Because it's coming as a result of the charge density. Okay. Now, if we take the same concept and take a look at the second equation, which basically says the exact same thing, except we're going to replace the E with the B, and we're going to keep this divergent behavior, we're going to realize that this is actually equal to 0. And you might be confused, you're like, what does it mean when it's equal to 0? Well, that means if you want a divergent magnetic field, if you want a magnetic field that behaves like this, that diverges and that doesn't curl, it's going to be caused by nothing. Nothing can cause that. It's impossible. At least to our understanding, based on physics, there are no such things as like magnetic charges or magnetic monopoles. There's no single thing that creates a magnetic field. We're going to see from the other equations later on that a magnetic field has to be caused by something else, which hence is the electric field. You can actually realize that the magnetic field is just kind of like a different kind of electric field, and they're kind of the same thing a little bit. So we know that from equation 2, which again is Gauss's law for magnetic field, is that if you want to see a divergent behavior in magnetism, guess what? You're never going to see it because there is no magnetic monopole, there is no magnetic charge. So again, to see how these guys compare to each other, this is going to be equal to rho, E naught, and this is going to be equal to 0. So if you want to have a divergent electric field, or an electrostatic field in this case, well, you just need a bunch of charges that are chilling, in this case, in free space. And if you're trying to have a divergent magnetic field, well, you're never going to find it, because magnetic fields cannot be created on their own. Which brings us to the third and fourth Maxwell's equations laws. So we're going to start with equation number 3, which is called Faraday's law. And it's pretty simple. It's basically telling you that the curl of electric field, in other words, the rotational behavior or the electric field doing this compared to like divergence, which is like doing that, is caused by something. It's caused by something pretty straightforward, which is simply a changing magnetic field. Right? And again, we want to look at this equal sign, where this right side is the cause, this is the effect. It's telling you if you have a magnetic field that is changing with respect to time, in other words, if you take a magnetic field strength and you see that it's changing with respect to time, you can even graph it. It probably looks something like this. Like let's say this magnetic field strength this time, and the magnetic field is varying. You take the derivative of this guy, you take the rate at which this magnetic field is changing with respect to this time, and that derivative is actually going to tell you the curl of the electric field. It's going to tell you that there's an electric field being induced at this rate. And this is something that's very, very powerful.
So a change in magnetic field, a change in time of magnetic field induces current. Induces an electric field around, creates a turbulence of electric field.
Discovered by Michael Faraday, and he was actually originally a chemist. He wasn't even a physicist, and he was an
So what's the experiment? How would you discover this? So a magnet, basically, if a magnet moves by, then it creates an electric charge. So if a magnet moves by a wire, or a wire moves by a magnet, if they move relative to each other, then you use the left hand 3 fingers to discover in what direction. Let's see how he explains it.
Experimentalist. He was a hands-on tinkerer type of guy, and he's just like running a bunch of experiments in his lab. And he knows that if you're changing the magnetic field, if you're passing some type of magnetic material, well, then you're able to induce an electric field. You're able to see an electric current as a result of that. And this is something that's actually very, very important. I want to pause here and make an extremely important point: is that some of the greatest physicists in history, they're not just people who are like doing math all day. Like there's this perception of physics that in the movies and whatnot, that like physicists are just like doing crazy equations all the time. But like the truly great physicists, such as James Clerk Maxwell, such as Michael Faraday, such as Albert Einstein, their advantage is that they had such a deep intuitive and visual understanding of what's going on. They were just such observational people. And Michael Faraday wasn't even that good at math. He had, I think, algebra was like his strongest. Like he didn't know more than like what people would consider high school math today. But what he was very good at is he was a very good scientist. He was very good at practicing scientific method. He was very good at coming up with an idea, running an experiment, and observing what happens, and then saying, "Oh, that's weird. Why did that happen?" And then just like thinking about it, trying to understand what it is. So if you're someone who's interested in engineering, math, or physics, it is very important that you actually try to understand physics, try to understand how it affects the world, and not just like do a bunch of equations and like write some numbers down and just kind of plug things in. Anyway, a little bit of a tangent, which brings us to the fourth equation, which is called the Ampere-Maxwell law. And it goes like this. Again, we have the still operator with the x. This is a curl. And it's basically telling you that, again, some type of rotational curling behavior in a magnetic field. If you want to induce a magnetic field that is rotating, again, not divergent, because we discussed that you cannot have a divergent magnetic field. And that is going to be caused by 2 things, right? And there's 2 people to give credit for this for. The very first one was Ampere. So this is called the Ampere law, where it's telling you that if you have some type of J, current density, basically an accumulation of charges that are varying, that are moving, and hence we measure current in the unit of amps, this in credit of Ampere, that's going to create a magnetic field. You can try that. If you're passing current through a wire, you're going to create a magnetic field. You can detect that there is a magnetic field. But then there's another way you can cause a magnetic field, especially one that's varying and curling, and that is you can actually change an electric field, just very similar to the Faraday's law, basically the reverse of it. And in this case, obviously, we have the permeability of free space, permittivity of free space. You don't have to worry about that. These are just some constants that are telling you, depending on what material you are, assuming they're in free space, the electric field or the magnetic field are going to behave a little bit differently. But what matters is that this is just dE over dt. So, I don't know if you guys can see that. So over here we have 2 things again, and this is a plus. Plus meaning these things are not depending on each other. You can think of this as like an OR date, where like if you have If you have current, cool, that's going to change your magnetic field. Or if you have changing electric field, cool, that's going to change your magnetic field. But they don't depend on each other. You need one or the other. So basically, Ampere made this observation, and then Maxwell made the observation of, no, actually, when you change an electric field, then you can induce a magnetic field as well. Now we know that in order for you to induce a magnetic field, you can do that either by varying an electric field, or you can do it by passing electric current through a wire. And that's pretty much it. Now here's the cool part, is if you take this equation, and the one we just looked at before, and by the way, these are obviously vector fields, and here we have just a minus dv over dt. If you take these two equations, and you combine them together, there's a way that you can combine them together, and what you derive is you derive the wave equation. And this is how electromagnetic waves are formed. For example, the light that's hitting me right now, from all over these lights, or the one bouncing off the board and hitting me, or the one hitting your eyes right now, it is traveling through the form of electromagnetic waves. There's an electric field that's like doing this, and then in parallel to it, there's a magnetic field that's like also oscillating with respect to it. And the changing electric field induces a magnetic field, the magnetic field is changing to induce an electric field, and they just do this dance infinitesimally. And if you take like the derivative of, like, for example, if you take sine, if you try to take the derivative of sine or cosine, and you just keep doing that back and forth, you'll notice that all you end up doing is you're just getting oscillating behavior. Now, I can make a separate video about this if you want me to talk a bit further about the wave equation or waves in general, or how you can go from Maxwell's equations to understanding waves. Then you can leave a comment and let me know below. But that's pretty much it. If you like this video, you can leave a like and let me know what you liked. If you did not like it, then you can leave a dislike and write a comment and say what you would.
What do you mean they're inducing each other? Why would you say that? So one of them cannot exist without the other? One of them will just die out? Why? Why would it die out? I don't see why. I mean, you can view them as independent.
Did not like about this video. I usually read every single comment, and I usually like or heart every single comment as an acknowledgement that I read it. And I do appreciate your feedback.
How many comments? 94 comments? Why did you say that the magnetic and electric waves induce each other? That doesn't, I mean, you can just say that they are independent each other. What's the difference? I don't know. What's the difference?
There's an electric field that's like doing this, and then in parallel to it, there's a magnetic field that's like also oscillating with respect to it. And the changing electric field induces a magnetic field. The magnetic field is changing to induce an electric field, and they just do this dance infinitesimally. And if you take like the derivative of, like, for example, if you take sine, if you try to take the derivative of sine or cosine, and you just keep doing that back and forth, you'll notice that all you end up doing is you're just getting oscillating behavior. Now, I can make a separate video about this if you want me to talk a bit further about the wave equation or waves in general, or how you can go from Maxwell's equations to understanding waves. Then you can leave a comment and let me know below. But that's pretty much it. If you like this video, you can leave a like and let me know what you liked. If you did not like it, then you can leave a dislike and write a comment and say what you did not like about this video.
You're a very good teacher. You are an amazing teacher. Maybe you can actually like solve problems and solve problems using these equations, so we get a better feel for them. You're an amazing teacher. Maybe you can actually solve problems using these equations so we get a better feel for them. Will he fall? If you can solve it, you can be an engineer. Hypercube distance? Well, this I love. I love these videos where they talk about what a PhD is like. Wow, this guy's buff.
Great decision.
in some specific cases. But for most people I know, getting their PhD arguably hurt their careers. I've spent a very long time in academia, ranging from very unknown schools all the way up to MIT and Harvard. And I've seen so many people start their PhDs for various reasons. I've also seen where they ended up after their PhDs. In this video, I'm going to break down exactly why and when you either should or shouldn't do a PhD. I'm also going to give some personal examples of mistakes that I've made that I wish I could tell past myself. I don't even want to get into this whole discussion about PhDs having to work crazy hours, minimum wage, anxiety, depression, stress, and all that stuff. I think we're all aware that PhDs are like this. However, if you're very ambitious, you want to shoot for the stars, I don't think that a few years of discomfort and low salary should get into your way. Instead, you should focus on what actually is best for your career. So what does a PhD really mean? You've probably seen this visualization of a big sphere that represents all.
There's something, look at his neck. His neck is offset. He has scoliosis.
Of human knowledge, and elementary school you learn kind of the basics in the middle, and high school is a bit more. Then during your bachelor's and master's degree, you slowly start specializing into one direction. Then eventually with your PhD, you reach the peak or the edge of human knowledge. Doing a PhD really means you become a researcher, researching some extremely niche topic. You're going to become the world's greatest leading expert in quantum effects and high energy rate propagation to intergalactic magnetic fields. And you know who actually cares about you being the world's leading expert in quantum effects and high energy rate propagation to intergalactic cosmic fields? Nobody. You'll spend 5 to 7 years of your life becoming the world's leading expert in something that nobody really cares about. I challenge you now, go on LinkedIn, exactly 0 job openings in quantum effects and high energy, whatever it is. The point I'm getting at here is not that you will be unemployed after your PhD. I'm sure you're going to find a job. The point I'm getting though is that unless you become a university professor, you'll have to get a new job in at least a slightly, if not significantly different field, which means you have to re-educate yourself. However, most companies just don't have the patience for you to learn new skills, especially not during economic down cycles such as right now. Why? You might be asking yourself. Well, let's take my startup as an example. A while ago, I was interviewing candidates for a new machine
There is a downturn right now.
learning engineering position. I received applications from brilliant PhDs, people who specialize in all sorts of quantum intergalactic stuff, or equivalent to niche fields, and I'm sure they were all very smart, and I'm sure they could have all learned the new skills to become machine learning engineers very quickly. However, why would I wait for someone who's overqualified in some specific field to learn these new skills if you could just hire some young person with 3 years of work experience out of college who went straight from machine learning engineering and doesn't need any kind of new education? The usual response people would give to this argument that the PhD is really about learning how to think. Once you learn how to think, you can learn any job in no time. You know what? I kind of call bullshit in that argument. I mean, yes, there is something to this. However, by the time you complete your PhD, you're probably going to be around 30 years old. You don't need 30 years just to learn how to think. That's like training for some sport for 30 years without competing, and then eventually going to a competition for the first time, well past your physical peak. It doesn't really make sense. Our brains peak cognitive functions likely either in our late teens or early 20s. After that, we really just become smarter by becoming more experienced and more knowledgeable about things. For example, if I was applying for some quant finance job and competing against 19-year-old me, I'm 29 right now, I wouldn't stand a chance. 19-year-old me was just so much better at figuring out crazy equations and stuff like that. So if your goal is just to learn how to think, I think you would be way better off to just go directly for your career and learn everything in 2 to 3 years, rather than spending 5 to 7 years doing a PhD. Obviously, there's some exceptions to this, but more about it later. And it gets worse, because during your PhD, you might be making backward progress. It was certainly the case for me and also for some of my colleagues. Because you know what skills really matter for your career? The technical skills are obviously relevant, but they alone will only make you become a glorified worker. You need to learn how to develop great social skills, how to negotiate, how to persuade other people, how to get along with coworkers and resolve conflicts. All these are super important skills which most likely won't be getting during your PhD. Most PhDs that I know ended up becoming lone wolves, working in their tiny little project with very little collaboration. And also, you should keep in mind that university professors are rarely good managers. After all, they're not chosen for their management skills like they would be in a company. Instead, they're chosen for their technical research skills. And even though you might get lucky, in probably the majority of cases, university professors won't really be able to help you become a better version of yourself and grow in your role as a person. Another common reason why I see people going to PhDs is because they don't actually understand what a PhD means. A PhD is a job. You work in exchange for money. That's pretty much the definition of a job. And it's not just any job, it's a job of a researcher. And if you're 100% certain that becoming a researcher is really what you want to do in your career, great, you're on the right track. But so many times I hear people say, oh my God, I'm not ready to go to the corporate world, I still want to stay in school and do a PhD. No, please get that idea of staying in school out of your head. A PhD is a career path optimized to make you become a researcher, usually as a university professor. But if you just want to stay in school after completing your undergraduate degree, just do a 1 or 2 year master's degree or maybe get an MBA or something like that. But not a 5 to 7 year PhD. This was a lot of negative talk about PhDs. As I said earlier, there exist specific scenarios in which it really does make sense for you to do a PhD. But right now, I can only think of 4 different ones. Number 1, if you already know that becoming a researcher is your dream career path, then doing a PhD is a very viable option. Most likely, if you want to become a university professor, this will be the most direct path. So if that's your goal, go for it. I actually made a whole video that you can watch talking about how to apply to all the top PhD programs. As a matter of fact, back in the days, it was my personal biggest dream to become a university professor. That's also the reason why I applied to a PhD in the first place. That's kind of foolish back then. The big caveat here is that becoming a university professor is ridiculously difficult, and people tend to overestimate themselves. As a matter of fact, some of my genius colleagues here at MIT and Harvard never made it. And frankly speaking, your odds of becoming a university professor become staggeringly lower if you're not doing your PhD at some top-tier university. I know it's unfair, but that's just how it is. You will be surprised about the amount of elitism that goes into professorship applications. Before MIT and Harvard, I studied at EPFL in Switzerland. And if you look at their internal directory, you're going to notice that the fraction of professors, new professors, who went to MIT, Harvard, Stanford, Caltech, and Berkeley, or other top US universities, is huge. And even though EPFL is a great university, usually ranking in the top 10 to 30 in the world, the fraction of my friends who did their PhDs at EPFL became professors after that at a decent school is staggeringly low. And almost all of them ended up doing some random engineering jobs later. Don't get me wrong, they're making decent money and having a good life, but it's just not their dream. And if they'd directly gone for these jobs before they did a PhD, or maybe just after some master's degree, arguably, they would be making more money right now. Number 2, another good reason to do a PhD at a top US university is because you can earn a free master's degree. It's true. After 2.5 years of doing my PhD at MIT, I dropped out and I received a free master's degree. Wasn't planning on it initially, but it actually worked out good for me. And on top of that, I got paid $50,000 per year. It's a great deal. And at the same time, my friends who were just doing regular master's degrees at the same university, they had to pay $50,000 per year. It's a win. So, what's the catch? Well, there isn't really any. I mean, you may have to do some research on the side while taking your courses, but that's really bad. However, admission rates for paid PhD programs are often by an order of magnitude lower than for just regular master's degrees. Allegedly, my PhD program at MIT Computer Science has an admission rate of around 1%, while master's degrees at Harvard University in computer science are about 10 to 20%, allegedly. The third reason why many foreign nationals apply for PhD programs in the US is because it's a great door opener to first of all move to the US and also become a permanent resident. As a matter of fact, I know quite a bunch of people at even MIT and Harvard who are really just doing the PhD for that reason. And you know what? The fourth reason might be that some traditional industries are specific to...
Boring. Oh, this is good.
I completely nuanced last year. A year later, do I regret getting my PhD? Yes, I regret. The main reason I regret getting my PhD is because what I'm doing now and what I want to do in the future has nothing to do with my degree. So it's like, I don't think I'm ever going to use my degree. I will share more details about why I regret getting my PhD. But first, I will break down some truths about academia and industry and why I don't think it was getting PhD in 2024.
I think everyone regrets going to school, like including kindergarten. Like you don't get anything from school, but yeah. Like I regret going to school. I regret so much. We're all full of regrets. She looks good.
Everything to ask is, can you read this at the back? All right, so if it gets small or starts sloping down the page, just let me know, we'll correct that. Okay, so we're going to start by recalling the informal definition of the line integral. So this will be familiar to all of you. So of integrals in one dimension. Okay, so it will be very familiar to all of you. You've done plenty of examples. So here, and we draw some function. Nice continuous function. Ultra of x. So delta of x is just a small increment in x. But the integral, so this will always be the case. So we consider a similar approach, R, our region of interest, R. So if I'm thinking of this in terms of its sort of physical interpretation, so if I have x and y now in the plane, and I have my third dimension coming up here, then psi is some scalar field, it's a surface. So here's where I challenge my ability to draw, but something like that. Let's suppose that's psi. And what I want to do is integrate that function over some region in the plane. So here's my R, and I want to integrate that function over that region. So what I'm doing now is computing the volume underneath that surface. So we do exactly the same thing. So this time, instead of partitioning the line into small intervals of width delta x, we partition the plane into small elements of a given area. So we can think about dividing this up into regions, and then summing, playing eccentric, summing all the volumes that are given between the surface over that small element in the plane, sum them all up, take the limit, and that will give me the double integral in this case. So we might suppose this has width delta x and height delta y. And we can say, again, we need to define some value of the scalar field. So let's suppose the scalar field psi takes the value of the ith element. So then, on partitioning the plane region R into smaller and smaller sub, and then taking the limit this time as the limit to 0. So I should have said it up here. So I'm going to define delta A to be delta x, delta y. It's just the area of that little region of width delta x and height delta y. But the limit as delta A tends to 0 of the sum. So now I sum over, let's suppose there are n subregions. So I sum, then the limit. Okay, and we define that to be, so this is definition, the integral over the region R. And to denote the fact we're integrating over an area, not over a single line or single variable, we use a double integral of psi dx dy. And in the last course you did last time, in introductory calculus, you've computed a lot of these double integrals of well-behaved region integrals, and there's even more variable. Often useful with matter, which way I integrate, whether I integrate to allow various properties. So let's start with the integral of b being as a times the integral of f over the region plus b times the integral of g over the region, exactly as you would have seen in integration of one variable. So then we have the property of order. So if we have that a function f of x and y is always greater than or equal to a function g of x and y on the region of interest, so for all x and y in R,
She killed him?
This is Dr. Grande. Today's question is, can I analyze the case of Rebecca Gay and John Douglas White? Just a reminder, I'm not diagnosing anybody in studio, only speculating about what could be happening in a situation like this. If you enjoyed this case, Luke's father's name was Thomas, and her mother's name was Sally. After graduating from high school in 2007, she attended cosmetology school. She worked at a hair salon after completing this program, but eventually took a job as a cashier at a Goodwill store. Rebecca lived in a trailer just east of Mount Pleasant, Michigan. This is a small town in Isabella County. This is about 2.5 hours northwest of Detroit. At some point, Rebecca was in a relationship with a man named Chad. They had a son together named Conway. That relationship ended, and Rebecca found a boyfriend named Aaron. Rebecca's mother, Sally, was engaged to a local pastor named John Douglas White. John lived in the same trailer park as Rebecca. His trailer was only 300 feet away. He would offer to help out with Conway, like care for him when Rebecca was at work, and drop him off to visit with his father, Chad. John White had some negative encounters with the criminal justice system in his history. On March 19, 1980, when John was 22 years old and lived in Battle Creek, Michigan, he invited a 17-year-old neighbor named Teresa Etherton into his basement. John stabbed her 15 times, but she managed to escape. In 1981, John was convicted of assault with intent to murder and sentenced to 5 to 10 years in prison. The judge recommended mental health counseling, but it was not mandatory. During the court proceedings, John's father paid for his attorney. The attorney never brought up the insanity defense because John's father did not want to pay for a mental health clinician to conduct the case. This failure led to John successfully appealing his conviction. The state didn't feel comfortable bringing the case to trial again, so they offered John a plea deal. His conviction would be amended to assault with intent to commit great bodily harm less than murder, and he would be released from prison. After that, John would be required to complete 2 years of probation and seek mental health treatment. John accepted the deal. About 14 years after the attack on Teresa, John once again found himself in trouble. On July 11, 1994, near Kalamazoo, Michigan, a 26-year-old woman named Vicky Sue Wall went missing. John was married at the time and having an affair with Vicky. She was his coworker. She was last seen entering his pickup truck in the parking lot of a supermarket. 6 weeks later, her badly decomposed body was found in a wooded area on East H Avenue. John told the police that Vicky overdosed on drugs and died. He dumped her body in the woods because he was afraid of being accused of murder. The state could not determine how Vicky died, so John was offered a plea deal. In May of 1995, he pleaded guilty to involuntary manslaughter and was sentenced to 8 to 15 years. He was released 12 years later, in February 2007. During his time in prison, John claimed that he made a miraculous transformation. He earned his credentials to be a minister and dreamed of being a pastor someday. In 2009, he was selected to be the pastor of a 14-member church in Mount Pleasant, Michigan. His dream had come true, but for others, it would be a nightmare. Now moving to the timeline of the crime. On October 30, 2012, Rebecca Gay went to bed in her trailer sometime after 10 p.m. On the next day, October 31, Rebecca did not show up for work. The store sent an employee to her trailer to check on her, but there was no answer and the door was locked. The employee spotted Rebecca's car at a bar called the Barn Door. This was only 800 feet from Rebecca's trailer. Rebecca's landlord was contacted and opened the door to her trailer. After discovering that she was not in there, the employee contacted the police. Investigators spoke to a bar worker who said that Rebecca's car was not at the bar when it closed the night before. Rebecca was supposed to pick up her son Conway from his father at 4:30 p.m. Right after she missed this pickup, the police searched her trailer and her vehicle. Inside the trailer, there was damage consistent with a struggle. There was also a stain on the carpet that could have been blood. In Rebecca's car, the police noticed that the driver's seat was pushed far back. The position of the seat was inconsistent with Rebecca's height. The police spoke to Conway's father, Chad. He told them that on Halloween morning, John White had dropped Conway off to him. The police went to speak with John and noticed that he had scratches on his hands and a cut on his nose. When they asked him for an explanation, John said that he was struck by a falling shelf. Initially, the police thought that his story was plausible, I guess because of all these senseless shelf attacks that occurred in the area. The police inquired as to when John last saw Rebecca. He said that he went to her trailer early on October 31. He never actually saw her because she was in the bathroom, but he spoke to her. They last communicated at 6:30 a.m. when John fell asleep on the couch in the living room. At 8:30 a.m., John was awakened by Conway. He then took him to his father, Chad. John agreed to take a polygraph, which is a machine that is supposed to magically determine if someone is lying. It is based on pseudoscientific nonsense. As John was being transported, the police searched his trailer and pickup truck. In his trailer, they found trash bags, a rubber mallet, zip ties, and several panties from Victoria's Secret. In the bed of his pickup truck, they found a broken necklace and blood. Investigators showed John photographs of the evidence found in the back of his pickup truck. He had no explanation for it and asked for an attorney. Not long after this, John changed his mind and wanted to talk to the police. He agreed to confess to Rebecca's murder if he was granted 3 wishes. He wanted life in prison, which is a strange request considering there is no death penalty in Michigan. John wanted to be separated from other inmates, probably because he was not going to win any popularity contests in prison. And he wanted to make a phone call to Sally Gay. John was permitted to call Sally. He said to her, quote, "You are the love of my life. You probably are not going to see me or hear from me anymore," unquote. He also told her that he loved her, he was sorry, and he could never fix it. After the phone call with Rebecca's mother, John offered a confession to the police. He said that on the night of October 30, he consumed 4 or 5 beers. John watched videos of people having sexual contact with dead bodies. This was a recurring fantasy for him. He had been obsessed with this for about 2 weeks and specifically had thoughts involving Rebecca. At 2 a.m., now on October 31, he walked over to Rebecca's trailer and made entry through an unlocked door. Rebecca heard the door open and stepped into the hallway. John beat her into unconsciousness with a rubber mallet before strangling her with a zip tie. He tried to clean up the trailer afterward. John put Rebecca's body in a garbage bag, placed the bag in the back of his pickup truck, and dumped her body in a ditch about a mile away. When he returned to the trailer park, he moved Rebecca's car to make it look like she had been abducted from the bar. He went to sleep in Rebecca's trailer and was awakened at 8:30 a.m. by her son Conway. In March 2013, 55-year-old John White pleaded guilty to second-degree murder. He was sentenced to 56 to 85 years in prison. John had a way of escaping his sentences early, and this was no exception. He ended up serving only about 5 months. On August 28, 2013, at 4:17 a.m., he was found dead in his prison cell. John White brought an end to his own life by hanging. I'm moving to my analysis. Here are my thoughts in a few areas that stood out in this case. Item number 1. Members of the church where John served as the pastor knew about his criminal history, but did not think he was capable of committing a crime ever again. They said that he had met the Lord and was a different person. After John murdered Rebecca Gay, the church member who hired him to be the pastor offered an explanation by saying, quote, "He was doing a lot of good in the community. He was doing a lot of good and Satan did not want him doing good, and Satan got to him," unquote. Another possibility is the Satan-free explanation that John never transformed into a person and always had a desire to commit murder. Item number 2. Not everybody in Mount Pleasant, Michigan was a member of the John White fan club. Some people found him to be a little off and said that he would freak them out. Rebecca also thought that John was creepy. She was thinking of moving away due to safety concerns. I think what happened here is that Rebecca needed John's help for childcare, therefore she did not act on her intuition. What do I think happened in this case? This is just a theory, my opinion. From a young age, John had an intense interest in sex, specifically sexual domination, and contact between living and dead people. When he was in the Navy, he would brag about visiting many sex workers all across the world. Later, when he was a long-haul truck driver, he was proficient at finding sex workers along the routes that he traveled. This behavior made John appear unnerving to some people, but most people who encountered him believed he was trustworthy and stable. He was able to build relationships and fit in with society. John struggled with his impulsivity. This combined with his intense sexual desire and led to serious problems. Every now and then, he would get angry and seem like a different person. It was like he was losing control. In 1980, John attacked a woman in his basement because he gave in to his desires. He did not care what the consequences were. He wanted to commit murder, and nothing was going to stop him. In that instance, his victim managed to survive. John should have been in prison for a long time, but a mistake by his attorney paved the way for John to be released early. John managed not to attack anyone for several years, but in 1994, while having an affair, he once again lost control. This time, his victim did not survive. As was his pattern, John made a jubilant journey from jail by sidestepping a severe sentence and securing a state of serene liberation. In prison, he attributed his behavior to the struggle between good and evil. He
He considered himself to be a good person with evil desires. He believed he could overcome those desires by embracing religion. John found living a murder-free existence. Electrons have an intrinsic property that is best observed with a modern version of the Stern-Gerlach experiment that used silver atoms. Here, we use magnets and electrons directly. The device has a north and south pole shaped to create a magnetic field that is stronger near the tip. This varies the force on charged particles passing through. A magnet is sent through with the north pole up and the south pole down. The magnetic field creates a force that deflects the magnet upward as it passes through the field. As we change the orientation of the magnets being sent through, we see the change in the amount and direction of the deflections. The deflections depend on the orientation. This is as expected. When electrons are sent to the field, they too are deflected. But they always arrive at the screen deflected either up or down, never in between like a magnet. Each electron behaves as a magnet, but with only one of two possible orientations, up or down.
How is it possible? Well, a magnet is just a bunch of electrons.
Intrinsic property of an electron is called spin. It is interesting to note that whenever an electron in an atom changes state, the atom's angular momentum.
But when you send an actual electron through a magnetic field, you have a completely different interaction. Because a moving charge in a magnetic field is deflected. And you want to avoid it. The silver atom is charge neutral. It only has spin. That's why we use silver atoms and not electrons. Photon spin.
Momentum changes. For example, here an electron moves from a higher energy orbital with angular momentum.
What do you mean photon spin?
To a lower orbital with no angular momentum. We see that the emitted photon carries away both the energy and the angular momentum, giving it a spin equal to 1. With the Pauli exclusion principle and spin as the fourth quantum number, the full set of spectral lines, orbitals, and geometries and interactions with each other fell into place. In fact, when we add this fourth quantum number to Schrödinger's equations, we can generate the entire periodic table of the elements. When we add the full spectrum, depend on the orientation. This is as expected. When electrons are sent through the field, they too are deflected. But they always arrive at the screen deflected either up or down, never in between like the magnets. Each electron behaves as a magnet, but with only one of two possible orientations, up or down. This intrinsic property of an electron is called spin. It is interesting to note that whenever an electron in an atom changes state, the atom's angular momentum changes. For example, here an electron moves from a higher energy orbital with angular momentum to a lower orbital with no angular momentum. We see that the emitted photon carries away both the energy and the angular momentum, giving it a spin equal to 1.
I have no idea what he's talking about. 0.
The intensity of the electrical currents dropped sharp. The two German physicists, James Frank Hertz experiments. In 1914, at a conference of the German Physical Society, the two German physicists, James Frank and Gustav Hertz, presented the results of an experiment involving collisions between low-energy electrons and mercury atoms contained within a vacuum tube. The results demonstrated that for certain electron energies, the intensity of the electrical currents dropped sharply.
Here, we have set up a modernized version of the experiment. Inside the heater.
Yeah, this is a simple experiment. This is very straightforward. There's nothing special about it. Yeah, the UN, the most evil organization in the world, they love climate change. That's Obama?
And tonight, former President Donald Trump holding rallies in Arizona and Nevada.
While Vice President Kamala Harris focuses on Georgia with help from former President Barack Obama. Dina Demetrius has a story.
My friend, the next president of the United States of America, Vice President Kamala Harris.
He's always looking from the side of his eyes.
Vice President Kamala Harris led a star-studded rally in Georgia, sharing the stage with former President Barack Obama for the first time during her campaign.
Thank you, Mr. President. Just 12 days left in one of the most consequential elections of our lifetime. And
Time. The determinant? Let me see.
So we are going to prove that the determinant of e to the a equals e to the trace of a, where a is any matrix. To start, let's talk about what e to the a means when a is a matrix.
the way that we define this exponential function, e to the a, is using the infinite sum formula for the exponential. So e to the a will equal 1 plus a squared over 2 factorial plus a cubed over 3 factorial plus a to the fourth over 4 factorial and so on to infinity. And using this formula, we can derive the results that we need regarding the determinant and the trace. Now, it's a little difficult to prove this result if A is an arbitrary matrix, but it turns out that it's a lot easier to prove if A is an upper triangular matrix. So the first question to ask is, can we convert this problem, where A is any matrix we're looking at, to a problem where A has to be upper triangular? And the way that we do that is with the Jordan canonical form. So when we're looking at matrices over the complex numbers, the Jordan canonical form says that we can write any matrix A as P times J times P inverse. And in this case, P is just any matrix, and J is a matrix that's in Jordan canonical form. Now, the details of Jordan canonical form aren't really important to us, but the important thing is that J is upper triangular. So in other words, we can always write our matrix A as P, J, P inverse, and we can guarantee that J in this expression is upper triangular. So if we can prove that this result is true for this J being upper triangular, how can we recover the result for an arbitrary matrix A given this equation A equals P, J, P inverse? Well, in order to figure that out, let's take a look at the form of e to the A. We saw here that it's 1 plus a squared over 2 factorial plus a cubed over 3 factorial and so on. What we can do is substitute P, J, P inverse in for all of these A's. So the equation will become 1 plus P, J, P inverse plus, and then here, we're looking at A squared. So in other words, P, J, P inverse squared. Well, let's write out what this means, because of course, when we square P, J, P inverse, that just means we're multiplying it by itself. So we have P, J, P inverse times P, J, P inverse. If you look right here, P inverse P, these two are right next to each other, so those are going to cancel out. That will just be the identity matrix, and then that won't affect the product because the identity doesn't do anything. So we're left with Pj times Jp inverse. So if we multiply these two j's together, we're going to get Pj squared P inverse. So Pjp inverse squared, we can basically take this 2 and then just put it above the j. And we can do the exact same thing with any exponents. If we multiply this 3 times, then we're going to get Pjp inverse, Pjp inverse, Pjp inverse. And so the P inverse P here will cancel, and then the P inverse P here will also cancel. And so we'll get P times J, 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 and then the P inverse at the end. And that will leave us with Pj cubed P inverse. We can do that for any exponent. So when we're looking at a squared, a cubed, a to the fourth, and so on, we can actually simplify those expressions a lot. Because this will be a squared over 2 factorial, that's Pj squared P inverse over 2 factorial, a cubed over 3 factorial, that's Pj cubed P inverse over 3 factorial, and so on. Now, here is the key. In all of these terms, we have a P on the left. We talked about how this book, the effect this book had on mathematics, but even humanity, apparently until the 20th century, and I don't know, maybe this, I don't think it continues to be the case, but this was the second most published book of all time, second to the Bible. So it's gone through, of course, Euclid wrote this in roughly,
Welcome to the 7th lecture in quantum field theory. Now we'll begin discussing the Laurent's transformation, and this is of course going to be a very important topic, very long topic. So if we want to be able to understand whether or not the Dirac equation that we came up with is actually Lorentz invariant, we need to understand what all of that even is. So we will take an entire chapter to talk about all of that, and right now we will begin just focusing on the Lorentz transformation. And we will do this from a relatively basic entry point, so that if you don't know much, and of course you need to know like some general notions, so of course you have to understand what they are, just the basic principles of special relativity, and from there we can work together just step by step. So the first thing that we need to understand is just the whole concept of these transformations that can happen to sets of coordinates. So let's begin by thinking back just to regular old rotations. So let's say, for example, that we have some coordinate x1, x2, x3, or x, y, z. So for example, if we want to transform the x1 coordinate, which is x, let's say that we apply a rotation, so under rotation, just so that we can build upon some things to make already know. So if we do a rotation, the way we do it is we multiply cosine of the
Since the positive charges are bound to the material, they themselves cannot adjust their positions to counter the Lorentz contraction. The last thing that might puzzle some people is why does the moving observer measure the distance between electrons to be larger than what the stationary observer measured? Well, as we just saw, the distance between the electrons does not contract. However, rulers in the moving frame do. And so, the moving observer will indeed measure this distance to be larger. So, I hope this explains what's going on a bit better. If you're not a math person and are satisfied with the clarifications I've given, you can stop watching now. Otherwise, I'll see you in a minute. Okay, let's now write down what the electric charge and current are in the moving frame.
Random variable is not randomly not a variable.
Hello, guys and gals. Me, Muhar, and I'm being blackmailed, ladies and gentlemen. Woohoo! Now, I'm like, wow, you look like the happiest person getting blackmailed, and I kind of want to talk about, this letter that I've received. And it's pretty goofy, pretty scary, chilling letter. It's got photos of my house, it's got my name, my number, and a pretty threatening demand letter. So let's start off reading this together. And obviously, I'm going to redact some information because it does contain an actual address, does contain an actual number, and does, of course, contain my name. So yeah, there's some private information to deal with. The letter starts off like this, like a real creepypasta, something on deep web browsing. Munahar, I know that calling blank or visiting my address would be an effective way to have a word with you. In case you don't act, don't try to hide from this. You have no idea what I'm capable of in Brampton. Now, for anybody that doesn't know what Brampton is one of the cities in the Greater Toronto Area, and it's one of the first places that I think I've really lived out on. At least got a house. I don't live in Brampton anymore. In fact, now I live much towards the. I guess I shouldn't even be in cardinal direction. I don't live in the city anymore. Okay, I live a bit away from it. Okay, it's important you pay attention to this message right now. We're all paying attention.
I want to find a... Whoa. Oh my god.
3 British climbers have recently returned home from their attempt to climb Mount McKinley in Alaska. It's 22,000 feet and the highest mountain in North America.
Oh,
The climbers were
13 years ago. Oh my god. Frostbite.
at the summit when they were caught in a blizzard. They suffered severe frostbite and hypothermia. You may find some of their interviews disturbing as they tell their own amazing story. Most people know it as Mount McKinley, and the local name is Denali, which they call the big one, the great one, and it's 20,300 feet. For the summit bit, we knew that it would probably take us all day. That's about
He's gonna lose his nose.
24 hours to reach the summit and get back down to our camp again. If we did it in less, then we were doing well. When we broke out onto the
So terrible that you can see the organ and it's turned black and there's nothing you can do. It's gone.
It was to be the adventure of a lifetime, scaling the highest mountain in the world.
You know, starting to yell out, I don't want to die, and that kind of thing, but it seemed to be kind of an unproductive thing to do.
And when Mike eventually stumbled into the camp at 1 a.m.
It amazed me that he was there at all, but he was absolutely exhausted. It wasn't incoherent. He was speaking.
Terrible.
3 British climbers.
Matrix manipulation.
This video is sponsored by Brilliant. Every matrix paints some kind of picture, while matrix manipulation or arithmetic tells a story. And that's not just the one of how boring this can be in school. At least for me, the beginning of matrices was one of my least favorite parts of math. So I wanted this to at least show you what this all looks like with cool 3D software, as well as an application I never learned in school. So here we go. When you're given a matrix, it can often be useful to think of it as a set of vectors. I'll be working mostly with 3x3 matrices, and you can think of these both as a set of 3 column vectors or 3 row vectors. We'll look into each. Where the column vectors come in immediately is when we use this matrix to represent a system of equations. Here, I'm sure most of you know this gives you 3 linear equations. For example, the first is 1x plus 2y plus 4z equals sum b1, and the rest of the matrix is all the other coefficients. But another way to visualize the same thing is to write it as a sum or linear combination of the column vectors, where x, y, and z are now just scale factors. Here, the first equation would be 1 times x plus 2 times y plus 4z equals b1, the exact same thing. So given some system to solve, you can visually think of this 2 ways. For the first option, you say, if I were to graph each of these, or in this case 3 planes, where do they all intersect? Because that intersection is our solution x, y, z, and in this case, it'd be 1, 1, 1. Now I'm going to switch to GeoGebra real quick because it's better for vectors. But the second option says to instead take the columns of our matrix and consider them as vectors, then find which scale factors are needed such that those vectors add tip to tail to get some other vector b1, b2, b3. So instead of an intersection, we're looking for scale factors. And in this case, all of them would be 1. Just add the vectors together as they are, thus 1, 1, 1 is our solution, just like we saw before. So we have 2 totally different visualizations for the exact same question. I like using the intersection one when I have to solve for x, y, and z, but when I'm asked what are the possible outputs here for b, then I like thinking of vectors. Now I'm going to change the matrix just a bit and also make the b vector all zeros. This then changes the other equations, and now let's go back to the 3D plot. Here we have
So welcome to our final day. Just remind everybody that the abbreviated, shortened program for the day. So it talks 9, 10.
But maybe I'm still at MIT, so I should not do that. And so let me tell you what this talk is going to be about, which is going to be entirely about some work that's joined with Anthony Conway and Mark Howell. And what we're going to study is some objects, which, well, it's sort of not very original. We're going to try to study a little bit about manifolds and a little bit about knots in them. But the context I'm going to be working in is that the dimension will be 4. And so in order to have a talk that contains me convincing you that we know really anything at all, I need to put some really strong restrictions on what kind of 4 manifolds I'm talking about. So I'm going to assume that pi1 of either the manifold.
Frank Hertz is so simple, but really interesting, obviously. Sterngerlach. Okay, I'm gonna finish. See you next time. Bye.